Hi everyone, this is Tanmay. So today we are going to talk about Docker. So if you are following me in my channel, you might know that currently I am running one MLOps playlist where I am teaching everything related to MLOps, including the theoretical steps as well as the practical part of it. So I have covered MLflow, DVC, Flask so far, and before starting any projects we need to know about Docker. So that is why I have come up with one one short course on Docker. So this video might be a bit longer, but I will try to cover as much as I can related to Docker. So let's get started. So today we are going to talk about Docker, and the very first thing that we need to know, why do we need Docker? So I will try to explain why we need Docker through a story. So in our story we will have one student and one magical lunchbox. Okay. So guys, meet Araf. Okay, he is an machine learning student and he trains a machine learning model on his laptop. He used Python 3.9, TensorFlow, NumPy, everything. Okay, and everything was perfectly fine in his system. Now the problem begins when Araf wants to run the model on his friend's laptop, deploy it on a company server, and submit it for a competition. But suddenly what happened? Model crashes, TensorFlow version not found, works on my machine syndrome comes up. Okay. So why it happened? Because each system or each laptop has its own different OS, has its own different Python version, has its own different library versions, right? So Arab spends days fixing environment issues instead of machine learning tasks. Okay, so that's why Docker comes up like a magical lunchbox here. So instead of giving just the code, what Arab did, Arab just packs everything: the code, the Python version, machine learning libraries, and all the system dependencies. So now wherever he goes, in his laptop, in his server, in the cloud, he opens the lunchbox or open the package, same test, same code, no issues. Okay, so no surprises, no crashes, right? So now let us understand what was happening without Docker. And now we are going to discuss a bit technical example, not a tougher one, but a very simple one. Okay, so let's say we have two files, train.py and requirements.txt. So you might know that inside train.py we write our own machine learning training code, and inside requirement.txt we have all of our dependencies, right? So now what we want, simple, right? We have to execute our train.py code, so we execute it on Mac, maybe on Linux, or might be on Windows system, right? But now these things are dependent on the Python versions as well as your CUDA versions, right? So now because these things are different, right? Because this each OS or each versions are different, so because of that version conflict happens, reproducibility issues comes up, as well as deployment failures happens. Okay, so that is why we needed Docker. And now we understand what is Docker. So Docker is a containerization platform used to build, package and run applications in isolated environments called containers. Again, we will dive about each of them further, but this is the definition of Docker. Okay, so at a practical level, Docker solves the problem of it works on my machine but not on yours. Okay, so how it works? So you have your Docker image. Okay, you have your Docker image in your hand and you can share it anywhere. People can run your code as is. That's all it is, guys. Okay, so now let us understand core components of Docker. So Docker has Docker engine, Docker image, Docker container, Docker file. So we will understand about each of them in detail further. Okay, okay. So what is Docker engine? So Docker engine is the main software that makes Docker work. It runs on machine or on server, and it is responsible for creating and running containers. Okay, so that is Docker engine in nutshell, and that's why we need to download Docker desktop. So if you're using MacBook or if you're using Windows or Linux, you have to use Docker desktop so that you can use this Docker engine feature. Okay, so now I will show you how you can install Docker desktop in your system. So right now I am in my MacBook and I will show you how you can download it inside the MacBook. Then I will show you from the Windows system how you can download there. Okay, so let's get in. So right now I am in my Safari browser. Okay, so inside Safari what I do, I simply search Docker desktop download. I search this now, and if you come up here, it's coming like, see, install Docker desktop on Windows, install Docker desktop on Mac. Okay, so right now I'm in my MacBook, so what I do, I'll just open it here, open a new tab. Okay, this is my new tab. Okay, so as you can see, it came up one documentation from Docker end, and as you can see, it has mentioned that, okay, Docker desktop for Mac with Apple Silicon, Docker desktop for Mac with Intel chip. Okay, so I had this Apple Silicon, that is why I have downloaded this one. You click any one of them and downloading will get started. Okay, and how you can open your Docker desktop once it is downloaded. You first install the Docker desktop. Once you have installed your Docker desktop, what you need to do is just come up here in your Launchpad section and come up in the Launchpad section and search Docker. Docker, yeah, as you can see, Docker is coming in my case, and if I click on this, it will start the Docker and it will come up like this. See, right now I do have a few of the containers running, so that is why it is showing like that, but in your case it should be blank if you haven't used any container before. Okay, so this is how it will look like when you install Docker desktop in your MacBook, and this is how it will look like. And now I will show you how it looks like when we do it on Windows. So right now I am in my Windows system and I have opened my Google Chrome here. So you may see that a screen a bit smaller. So I try to zoom a little bit so that you guys can see it. Okay, so what I do, I'll search here Docker desktop download. If I search it like that, again same thing is coming like it was coming in my Mac. And now you can click on this install Docker desktop on Windows. Just click on that, download any three of them. So what I have downloaded this one. Okay, so you can try to download this one, or you can try to download this one. Any three of them should be fine. So once you have downloaded this, what you can do, come here, search Docker desktop. It will come up like this in your Windows system. Click on that, and it may take some time to load in my system. Yeah, so as you can see, it came up like same. Again, I'm using a bit different account here, so that is why it is coming like that. But yeah, again, in my Docker desktop, again I have multiple images that I created before. In your case, you will not see anything like that because you haven't created any images or any containers so far. If you have created any images, you may see some of them here, but again you don't have to focus on this. But this is how the page will look like when you first time downloaded Docker desktop in your Windows system. Okay, just a sec. Okay, so as you've installed Docker desktop in your system, that means now you can access Docker engine. So Docker desktop is nothing but it's the Docker engine which will help you to do your stuffs. Okay, so what Docker engine does, let us understand. So it builds Docker images, it runs containers from images, it manages network and volumes, and as well as it communicates with Docker commands. Again, what is image, what is containers, what is network, what is volume, we will understand about each of them in detail further, but this is what it does in nutshell. Okay. So now we try to understand a bit more details about Docker engine. It's like some key points of Docker engine. Okay, so Docker daemon, what it does, it runs in the background and does the actual work. So Docker daemon is the thing which will run in the background and which will do the actual job. Next, Docker CLI. So this is where command line tool you will use. So we will execute some commands. Okay, so Docker CLI we are going to use for that. Last one is REST API. So this allow tools like Docker desktop or any CI/CD system to talk to the daemon. Okay, so below I will show you through one kind of a visualization. So this is the Docker CLI, and inside this Docker CLI only you are going to write your commands. Okay. Now through some REST API, it will communicate with Docker daemon, which will be running in the background. Okay, and then it will go towards the Docker engine, which will do the job, or whatever task or whatever command you have executed through the API. Docker daemon will send it to the Docker engine, and Docker engine will do its job. Okay, great. Now let's talk about Docker image. Okay, so what is Docker image? So Docker image is a template used to create containers. So it will be kind of a, I would say, a blueprint. Okay, a blueprint or a template which will be used to create your containers. So now let us understand what it contains. So it will contain the base OS system. It can be Alpine, it can be Ubuntu. Base OS it will contain. Then it will contain the programming language, and right now I am assuming Python will be the programming language. Then the application code, whatever code we have written so far, those code will be there. Okay, and then the dependencies, what all libraries and all we needed, all these things will be mentioned there. Okay, and few characteristics that we need to know about images. Images are read only, images are built-in layers, and multiple containers can be created from one image. Again, how to create them, that we discuss, but this is the characteristic of Docker image. Okay, so if you really want to understand about Docker image like a very layman term, so an image is like a cake recipe. You can bake many cakes like containers using the same recipe, that means using the same image. Okay, the next is Docker container. So a container is a running instance of an image. So we create container from the image only. So that is why we are saying that it is a running instance of an image. Okay. Generally it is lightweight. It is isolated from other containers, and it uses the host OS kernel. What does that mean, host OS kernel? So whatever you are going to host your application, right? Whatever system, like let's say I have built this on my MacBook. I have built my machine learning code on my MacBook, right? So now tomorrow I have used the same Docker image inside my Windows system, right? So this is my host. So my Windows system OS is the host. So that is why it is saying it uses the host kernel. Okay, and it starts and stops so quickly. Okay. So how it works, if I really try to explain how container runs or works, so it tries to load the image first, then writable layers will be added, and then application starts inside the isolation. Okay, again this is a very I would say a very straightforward definition about container, but we will again try to understand when we execute our commands, so that we can see and we can understand better. Okay, but in nutshell, if you really want to see that how Docker container runs, first image will be loaded, then some layer will be added, and after that your application will start in a isolation. Okay, so if an image is a recipe, a container is the actual cake here. Okay, so next one is Docker file. So a Docker file is a step-by-step instruction file that tells Docker how to build an image. Okay, this is simple as it is, guys. It will be a simple file where you will mention what code you needed, what dependencies you need to install, all kind of instructions line by line will be given inside this Docker file, and using this Docker file only we will create our Docker images. Okay, so these are the few basic commands like from, work directory, copy, run, entry point. So these are the few commands that can be used to create an Docker image. So this all things will be mentioned inside the Docker file, and when we do the practical on that time we will try to understand more about them. Okay, so Docker file is like a written cooking instruction for creating an image. Okay, next is Docker registry. So what is Docker registry? So a Docker registry is a storage system for Docker images. Now once you have created your Docker images, right, you have to store it somewhere, correct? So that is why you need a Docker registry where you will store it. So in our case, when we do it for local, right, so in local, if you see, when you create any Docker images, you can see those created images in your Docker desktop only. Okay, but when we talk about production graded systems, or when we talk about building something on cloud, on that time things happens a bit differently. Okay, so first of all we have Docker Hub where we can push our code publicly. Okay, so publicly people can access our images through Docker Hub, which is our online place where we try to upload our images. Another one is AWS ECR or Elastic Container Registry, which is a service provided by AWS, and inside that also we can register or we can store our Docker image. Now from Azure side or Microsoft side, they have Azure Container Registry, and for Google side they have Google Artifact Registry. Okay, so our registry is like a cloud cupboard where images are stored. Okay, so now we do the demo now. So we will talk about very basic commands using hello world Docker image. So now what we do, we try to run some commands so that we can see how we can pull an image or how we can create an image or how to upload something on image, right? So we'll try to explore all of it now. So right now I'm in my Safari browser. Okay, so and as you can see, I have just simply searched Docker Hub, and I just quickly click on this. If you click on this, it will come up like this. Just do the sign in, click on the sign in button. This is my email ID using which I had created my Docker Hub account. If you do not have that account, you can easily create it. Okay, so just click on the sign in and it will log in here. Yeah, so as you can see, we have logged in my Docker Hub page, and these are the repositories, okay, which I created. Okay, so this all contains the images. If you see, okay, these are the images that I uploaded inside Docker Hub. But right now for you, if you are very new user or if you haven't used Docker Hub before, in your case you may not see such things. It should be blank in your scenario. Okay, so now what we want to do now, click on this explore page and just search here hello world, because now we are going to see the very basic things, how things happens. Okay, if I just click on this, so as you can see hello world, you can see this icon and hello world is this Docker official image. So officially Docker have uploaded the official image that is from Docker, and that is the hello world. Okay, so as you can see, it has 1 billion plus downloads and it has 2.5k stars. Okay, so it is an example of minimal Dockerization. So whenever someone wants to really learn Docker for the very first time, they have kept one image. Using that, people can easily learn how Docker image works or how you can execute different commands to do some steps using Docker. Okay, so as you can see, this is the Docker page. You can see different tags are mentioned, as well as different shared tags are mentioned, differences are mentioned. Okay, so if you see, it has few tags. If you see, there are multiple tags provided by Docker. Okay, and as you can see, last update is 6 days ago. So 6 days ago, this image was updated, and the size of the image is 189.9 MB, and it is a image. As you can see, it has mentioned it is image. So now how we can pull this image in our local system, that we are going to see now. So now for that, what you need to do, you simply need to go and search your command line interface cmd. Let me search command. Sorry, I'm using Mac, I forgot. So this is the terminal. Okay, so this is my terminal where I am going to execute few Docker commands. Okay, so if I really go back to my Safari, you will see recent tags, and the different tags are mentioned from Docker end. But right now what I want to use latest version. That means I am saying that I want to use the latest Docker version. Now this image is inside the Docker Hub, and now if I need to use that image in my system, what I need to do, I need to simply pull that image. How to create that image, that we discuss later. But right now, image is already created by Docker. What we are doing, we are simply pulling that image in our local system. Now to pull that, these guys are given the command. Just click on copy. Docker pull hello world. I just go back to my terminal. I simply paste this code. Docker pull hello world. If I really execute this code, so it is asking for permission. I'll just allow it, and you will see that it will try to pull the image. See, it has done some pulling, right? You can see status downloaded newer image for hello world latest. Now my image is pulled in my scenario, right? So that means this image is now inside my local MacBook system. So if I run this command docker images, images, you can see these are my images pulled in my system. So few of them I have created before, so that is why you can see this housing streamlit latest housing, a build kit thunder 1234 housing streamlit housing latest. These are something I created before. Okay, but right now I have pulled hello world latest, right? You can see hello world latest. So this is what I just pulled. Okay, so this is now inside my system. As you can see, it is eating my 22.5 kb disk usage right now. As you can see, it is very lightweight, guys, only 22.5 kb. So my disk usage are 4 GB 5 GB, because again this is a end-to-end application that I created before, so that is why this size is showing like 4 GB 5 GB. Again, we are going to discuss about this later, but right now let's not focus on this. Right now let's focus on this hello world. So as you can see, we have pulled that image, and now how to execute that image. Now to execute, simply have to run docker run hello world, because this was the name of the image. Simply execute it. See, so when I have executed this code, so inside that image, right, as I already explained, inside the docker file we generally give instruction what will happen when someone execute my image. So that's why I have executed the image. That's why I run the command docker run hello world. So when I execute it, what happens? It has printed like hello from docker. This message shows that your installation appears to be working correctly, and to generate this message, docker took the following steps. Docker client contacted the docker daemon. Docker daemon pulled the hello world image from the docker hub. Docker daemon created a new container from that image, which runs the executable that produces the output you are currently reading. The docker daemon streamed that output to the docker client, which is sent it to your terminal. Okay, so this is what it is showing up. So this all data, or whatever have been printed so far here, this all are mentioned inside that image instructions. So that is why when you have executed this docker run, I executed this docker image in our case, so that is how it is printing things up, right? So this is the very basic demo I wanted to show you. Now further we discuss more about docker, and we are going to more deep dive about docker now.
So now what we do, we already know how to run few docker commands. So what we do, we try to understand few more commands that we can use in our day-to-day life. So that is what we are going to discuss, and that is divided into multiple sections. So I am going to cover those sections now. So the first section is pulling and running Ubuntu Docker image. So Ubuntu, you know guys, it is a kind of a OS system, right? So you can pull Ubuntu and run Ubuntu in your laptop. Now what we are going to do, we are going to do few steps inside the Ubuntu OS using the Docker image, so that we can understand what are the ways we can use Docker. Okay, so I just wanted to give you a glimpse of how you can use this Docker commands to do multiple steps. Okay, so there are few commands that we discuss about Docker pull Ubuntu. So if you execute this command, you will be able to pull the image. Then Docker run dash it Ubuntu. This will help you to run interactively with the terminal. I'll explain what does it mean interactively here when we execute the command inside our terminal. Then who am I? Cat etc os release, apt update, apt install dash y curl version exit. So these are the commands that you can see there. These are the 6 commands, I guess. So these commands we are going to execute inside the Ubuntu. Okay, so once we pull the image, right, after that we are going to execute few commands inside this Ubuntu. Okay, so I will show you how you can do this stuff. Okay, so this is our first motto for this section. So for this, what I do, I'll just go and search terminal here, so that I can show you how we can execute different commands. I'll just quickly clear my terminal so that I can show you properly, and I will try to make this screen a bit bigger so that I can show you. This command that we are going to run, that is docker pull Ubuntu. If I execute this command, what it will do, it will pull the Ubuntu image from the Docker hub. Okay, so as you can see, it is pulling the it is pulling the Ubuntu image from the Docker hub, and we will wait till it is getting pulled. So the next command that I execute, that is docker dash it, docker run dash it Ubuntu. So I already told you it means interactive. What does it mean here? So when we use dash it here, dash I mean it keeps the standard input open or std in open. Okay, and when we give dash t, it gives us a pseudo terminal. So what happens when I execute this dash it, it will give me a pseudo terminal where I can execute few commands that we generally execute inside Ubuntu terminal. Okay, so dash I means it keeps the standard input open, and dash t gives you a pseudo terminal. So that's how we can execute our commands inside Ubuntu, whatever commands we generally execute inside Ubuntu. Okay, if you don't use dash it, right, this container that is getting created, right, that will immediately exist. Okay, that will immediately exist because Ubuntu has no long running process by default. Okay, so that is why we need to run it through interactive way. Okay, so if I really execute this code, you can see my pseudo terminal came now. Right now I'm inside my Ubuntu. Now I can execute all the commands, whatever possible commands are there for Ubuntu, we can execute. And in the PPT I have already showed you what are the commands we are going to execute, so that I can show you that okay, we can use these different commands inside the Ubuntu server. So first command is who am I. If you execute this, who am I, sorry, it was wrong, yeah, this is a root. So I'm using the root account inside Ubuntu, that is why it is saying root. Okay, the next command is cat etc os release. If you execute this code, it will give you all the information related to the OS. You can see name is Ubuntu, PT name is Ubuntu 24.0.4 LTS, name Ubuntu, version ID, version blah blah blah. This all details are provided inside that. Then apt update. When you execute this apt update command, it will try to update all the packages available inside the Ubuntu. So generally, if you create an Ubuntu server, you generally execute this line always. If you haven't used Ubuntu before, that's fine, but this apt update will help you to update all the packages available right now inside the Ubuntu. So in future, whenever we are going to deploy a solution on Ubuntu, right, I mean through the cloud server, on that time we need to execute this code to update all the available packages inside Ubuntu. Okay, so if I execute this code, you can see it will start updating things inside the Ubuntu. So let's wait till its completion. Now curl is installed. So if I really want to show you that curl is really installed or not, I can execute this command curl adjust version. If I execute this command, it will tell you the version of the curl. It is saying 8.5.0. That means curl installed successfully inside this Ubuntu. Correct? Now I am done with this step, so I need to exit from this Ubuntu terminal. So what I do, I just call exit. If I call exit, I am out of the terminal. Okay, so this is the thing that I wanted to show you. Now next, this was all about section 1. Now section 2. Container lifecycle commands. So docker ps command you can use to show running containers. Docker ps-a command you can run show all containers including stopped ones. Then docker start-i container id, it will restart the container that you have stopped. Then curl version exit docker rename a container for easier reference. Okay, so curl version is nothing. I'll just go inside the container just to show you that it is working. So that is why I kept these two commands. And this is the command. If you want to rename your container name, you can rename it through this way. we talk about them. So docker ps dash if you call, it will show you the new name after that. Okay, so once you give it a rename, right, once you execute this command again, it will show you the new name. So we will discuss about that part now. So again, I'm coming back to the terminal. I'll just do quickly clear so that I can clean my terminal. So first I execute docker ps. So I have executed docker ps, as you can see in my case. Container id uh, image command created. This is all the names created, status is all things are coming. Okay, so if I really try to make it a bit smaller, you can see it properly. Yeah, see the container id, image names, command created, status, ports are coming. So container id means when we pulled that image, right, it will create a container. Okay, so that is why it will have a container id. Then what is the name of the image that we pulled? This is the name of the image. Again, this is the airflow image. Okay, but for now you don't have to worry about it, but I just wanted to tell you that, yeah, so this is the image of airflow. Okay, so this is the command. Then when it was created 2 days ago, it was created. What is the status? It was up for 13 hours. And what is the port through which we can connect with this? That is 8080 TCP port. Okay, so what it is showing this. So if you by default execute docker ps, it will show you all those containers, those are running right now. So if I just open docker quickly, so if you see, so if I open docker, in my docker you can see these airflow things are running. Correct. Again, this is not related to our current tutorial, but I just wanted to show you. Let's see, these things are running. You can see these all are running. These are all running. That is why when I execute the docker ps, I got these containers, right? Because these are running right now. Now, if we execute docker ps dash a, you will get all the containers, including the stopped ones. So, if you recall, we we created one Ubuntu container, right, and we exited from it, right? But we just exited from it. That means it is stopped. It is I have not deleted it, right? It is not running right now, but it is there inside my system. So it is stopped. So if you execute docker ps-a, you can see that. So you can see Ubuntu is coming here. This is the Ubuntu container ID, and when it was created 6 minutes ago, and what is the status? Exited 3 minutes ago. So you know, guys, just 3 minutes ago I exited. So now what happens? Let's say I want to start this Ubuntu container again. Okay, Ubuntu again. How I can do it? I just simply say docker start dash I, then the container ID. This is the container ID. If I pass this code, see, again I came inside the Ubuntu. It means it is started now. Okay. So let's say if I really execute the same commands, who am I? Who am I? Sorry, I typed it wrong way. Who am I? CD showing root. Then if I say apt install dash y curl, it will again happen. So curl is already installed, like last time we installed curl. So that is why it is now not installing it. It is just saying it is there already, not upgraded. Okay. So now what we do? We simply say curl dash dash version. See, it is showing the version. That means whatever we did last time, it is still persisting that part. Because we have not deleted it, we just stopped it. So that is why it is persisting its last state here. Okay. Great. Great. So now what we do? We try to exit from this. Right? We have exited from this. So now what we do? We try to rename this container that we created, right? So how to rename it? Just say docker rename the container ID. This was the container ID. Then let's give it a good name like my Ubuntu. So, so before it was named as Ubuntu. If we try to change its name, right, you can change it my Ubuntu. So now if I do docker ps dash a, can you see showing my Ubuntu? So it was named before hopeful more. Now it is showing my Ubuntu. So I have changed the name of the container. Again, I have not changed the name of the image. I have changed the name of the container, because image name you cannot change it because it is there inside the docker app. You can change the image container name inside your system. So that is what I did. Okay. So this is the one part that I wanted to show you. Now the next part, that is section 3, running with custom names and detached mode. So we will talk about running with custom names and detached mode. So this is the command that we execute, run with a custom name. So if you really want to execute your docker image, okay, or you want to execute your docker container here, right? So what you need to do, you can need to execute this command so that you can use your custom name. Okay. Then next we can install these commands like again apt update we used last time. Now we install Python inside Ubuntu. Okay. So I just wanted to show you a few more commands that I can show you that okay, it is really working. Python 3 version we check and we execute this exit command. And then we execute this command to run in detached mode. What is the detached mode thing that we discuss when we implement it? Okay. So you will execute these commands. So if I quickly come into that page, so I just quickly clear this part so that we can execute it properly. So execute docker run dash it dash name. Now we pass the custom name. Let's say MLOps Ubuntu. Okay. Then the name of the image, that is Ubuntu. Now see, again it came, right? So now just to show you that it is still working, I will execute this command apt update, then uh, and apt install Python 3. Okay, and I forgot to give dash y. I have to give dash y. Okay, so then execute this command. So what it will do? It will install. First, it will update the packages available inside Ubuntu. Then it will install the Python 3. That's all it will do now. Okay. Okay. So it is asking us to choose something. Like I chose 9. I'll choose anything random for now. Okay. So yeah. So Python installed successfully. Now to confirm that it is installed properly, what we do is execute this command python 3 version. Okay, if I execute this command, it will confirm me the version of Python. So we have installed 3.12.3 version of Python. It means that it is working perfectly fine. Okay, so what we do now is simply exit from this. Okay, great. So now let's see the containers running right now. You can see same names are coming. If I do docker ps-a, we can see that, see, MLOps Ubuntu came up. Now, this MLOps Ubuntu is different than my Ubuntu. So you can recall just few minutes ago we created my Ubuntu, right? And now we used MLOps Ubuntu. So now when we use the custom name, it created a new Ubuntu container from the image. It is not the same Ubuntu that we did in the a few minutes ago, right? This is the separate Ubuntu container that is created because we used a custom name. Okay. So for this it has a separate container ID. For this it has separate container ID, and that is why we had to execute apt update again to update all the packages inside the container. Okay, so this is what I wanted to show you here. So now the next command that we are going to do, that is executing something that will do some stuff. Okay, so we execute this command docker exec. Okay, here exec means simply execute, you can think about. So uh, let me just type it, execute background uh, container. I giving it a name like just it background container bash. Sorry. So now I am going to show you one more command, docker exec dash it background ground ubuntu bash. If I execute this command, so now I am going to show you the detach mode that we discussed last time, right? How this detach mode will work. Docker run dash d. This dash d means now the detach mode. Okay, it means once you execute this Ubuntu in detach mode, then even if I turn off my terminal or if I close the terminal, still it will this Docker container will be running in the background. It will not stop it. Since we were using dash it, which means interactive mode, that will give you the pseudo terminal. Right now we don't need a pseudo terminal, right? I just want to run in a detached mode, that is why we are doing that. Okay. Docker run dash d if I execute, then dash name. I pass the name like background task. This is the name of the um, custom name of the Ubuntu container, right? And then I give them the Ubuntu. So this is the name of the image, correct? If I execute this command, it will show you the ID. It show you one ID. Okay. So now if I do docker ps, we will not see Uber background task named anything. Why? If I do docker ps -a, you can see it. and you can see that it is saying it exited 21 seconds ago. Why it is exited? Because we have not executed any command inside it, that's why. So okay, so what you need to do, you just go here, just give some command like sleep 300. I'm just executing some commands just for namesake. So again, sorry, already there's something already created. That's why it is saying container name is already exist. So I try to create a new one like task 2 executed. See, now if I do docker ps, so now you can see this is running in detached mode. See, for sleep 300, now it's running 4 seconds ago, up for 4 seconds. Okay, so now if I really execute some commands, how we can do that? Now since we were using in interactive mode, we were able to use it, right? But now the scenario is we need to execute the same thing in the detached mode. How we can do that? So for this we need to execute this command docker exec, then dash it background task 2 bash. If you run this command, so now we are inside again the Ubuntu like we were before. Now you can execute any command. Now I have executed this command echo I am inside Ubuntu. So this is one command that we use to print something inside Ubuntu. So again it is working. It means that I am doing it correctly. So now I will be exiting from this thing again. Okay. Okay. So now we talk about the last section, that is the cleanup commands. So these are the commands that we can use to clean up our things that we created so far. So the first thing is docker stop background Ubuntu. If I execute this command, it will stop the running container. Then if I execute docker rm my Ubuntu, docker rm MLOps Ubuntu background Ubuntu, then remove the Ubuntu image. Okay. Then if I do rmi Ubuntu, it will remove the Ubuntu image. And if you execute docker image, it will show you what are the images available inside your docker. Okay. Then docker image prune a will help you to remove all the unused images. Docker container prune image nuclear option remove all the stopped container at once. So these are the commands that we can use to do something. So now the few things that I need to tell you, that is here all the commands that I am showing you I cannot execute because in my system I am doing some projects for your further content. So that is why I cannot execute the docker container prune docker image prune a. Okay, these commands I cannot execute in my system because if I execute, it will remove all those containers that are created inside my system. So if I delete them again, creating them is a lot of headache for me. Okay, so that is why I'm not going to execute these commands, but you can execute these commands in your system if you want to, no problem in that part. Okay, so I just quickly go to the terminal. I execute this command docker stop. See, this is running right now, so I want to stop this one, so I execute this command. See, so now if I again to docker ps, see, the docker task 2 was running, right now it is not showing up here, it means dropped it. Okay, if I execute docker rm my Ubuntu, so my Ubuntu, the container that you created, right? So if I execute this command rm, right, it will remove the container. So see, so if I do docker ps dash a, see here also you cannot see that my Ubuntu because it is removed. Same way if I want to execute this code, docker rm, let's say MLOps Ubuntu, MLOps Ubuntu, if I execute, or if I execute this background Ubuntu So if I want to remove multiple container altogether, so I'm deleting multiple container. This background Ubuntu 1, I remove this one too. Then background task, this. So I'm trying to remove all these containers that I created so far. Okay. See, now if I do docker ps-a, so you cannot see those containers anymore because I removed all of them. Okay. So now finally what I want to do, if I execute docker images, you can see these are the images available. Ubuntu, Redis, Pro and other things are there. Right. So what I do now, I simply remove this Ubuntu image itself. Now to remove the Ubuntu image, we need to do docker rmi Ubuntu. If I do docker rmi Ubuntu, it will remove the image. So if I do docker images now, so Ubuntu you cannot see it. Okay. So this is all how it works. Okay. So you know, right, guys, we are learning this inside our MLOps playlist. So in MLOps, you will be building and testing images constantly, and if you don't clean up, Docker eats your disk space fast. So that is why you need to be so careful while creating your images for testing or for building, and make sure that you remove the unused ones so that it will not eat your disk space. Okay, so that's all I wanted to show you in this section.
So now we will be continuing with further Docker things. So far you have understood different commands on Docker and you have understood how to implement them. Now why I want to show you something that will make you more motivated. So I am going to show you one project. It's a simple machine learning app that I have built, and I will show you how it is working and all, and the code is also ready here. And then we will create a Docker file. Okay, and we are going to dockerize our project, and I will show you how you can do that, how you can create files, how you dockerize them, so that we will get that feeling, because we know how commands work, right? How commands work, we know how they do what they do, right? Now let's do it in a project so that we'll get that understanding better. So while doing this project, you will see few commands that I will be using, maybe new to you or maybe something that I have already discussed. Okay, so this way you'll get more idea about it. Okay, so let me explain you the project. So right now, because we are working on Docker, so I'm not going to write the codes in front of you. Code is already ready from my end. I'm just going to explain it to you. So later on, once this Docker video or Docker video is done, then I will do end-to-end project. In that project, we will be doing something good. Okay. So you can see there is something file called app. Inside this app folder, I have few file called init.py, predictor.py, routes.py, and schemas.py. So simple. Predictor.py contains the code for prediction. Okay, and you can check the code. Okay, I'll just share the GitHub repo link. You can check the code. And in this project, I have used Iris dataset. You know, right? Iris predicts three things: Setosa, versicolor, virginica. Okay, this is what it does, and that's why I created one predictor.py. It will be predicting based on some input features. It will be predicting is it a Setosa, is it a versicolor, or is it a virginica. Okay, I have some called routes. So this is the fast API routes that I have created here: health route, predict route, and all. Okay, so if you don't know about fast API, don't worry about that part for now. Just go through the code, nothing much. Okay, we will be having one full course on fast API also after this Docker video. Okay, so don't worry about that part. Then schema. So few pydantic schemas I have used here. You can see them here. Okay, now inside the model, I kept loader.py and train.py. So train.py contains the code using which I have trained my ML model, and loader.py is the code which will load the model, and the model is model.pickle file. You can see this is the model.pickle file. Okay, then
Statics. So statics contain the information related to the UI, the HTML, CSS, JavaScript, everything. And main.py is the actual code where this whole fast.py thing will run and we can see our stuff. Okay. Now this is called requirement.txt, and in this requirement.txt we mostly mention our dependencies, and so that we can install this dependency to run our code. Now before starting our project, right, what I need to do, I need to simply create one new virtual environment. So now for that you need to run the command python 3.12 that's vnv dot development. So if I run this command, it will create a new virtual environment in my system. You can see it here. And to activate the environment, you need to run this command source dot development bin activate. So you can see development here, right? That means my environment is activated. Now to install all these dependencies, I need to run this simple command pip install -r requirement.txt, and you will see it will start installing all the dependencies mentioned in this environment. Okay, and once these installations are done, then we will be executing our code. Okay, so I just simply execute the code. If we con main :app, that's just port 8000. So this is the command that I am executing right now. You can see the command. Okay, I am executing this command right now, and let me just click on enter, and you will see the app will run. Give it a second because sometimes it take a bit time to get executed in my Mac. Let's wait for it. You can see the app is running right now. I go to my Safari and refresh the screen. So you can see localhost 8000, right? As I refresh the screen, you will see that it is running, right? And what I do, I quickly open my Docker and I quickly quit my Docker. Okay, my Docker was open in my laptop and I'm just quitting the Docker for now. I just refreshing the screen. You will see that things are running now. You can see I have to pass sepal length, sepal width, petal length, petal width. So these are the input features that I need to pass. So if you drag it now, it will be bigger than. If you drag it like this, it will be lower than. Okay, and if I drag it, you can see for the petal length maximum value is 7, for sepal width maximum value is 4.5, for sepal length also maximum value is 8.0. So like those values are there, and if I click on classify species, you will see it will be predicting the iris classifier. Okay, it will be predicting what kind of flower it is. Okay, so it is a virginica. Okay, you can see large snowy flowers with broad petals, grows in eastern US, coastal plains and marshes. Okay, if you change this feature, you will get some other value. Now see, for this inputs you are getting it versicolor. So based on this inputs we are getting the answer, and you can see other prediction probabilities also here. Okay, so now what I am going to do, the app is running right now inside my system, right? Now what I do, I create a new Docker file, and inside the Docker file we are going to run the exact same thing. So how you see how you can Dockerize your project, and then you can see how you are going to execute your Docker file so that it can run as it is. Okay, so for that what I need to do, I need to go back to my VS Code, and I just quickly stop this one for now and just I call it clear, and I open my Docker file. Okay, I make sure I open my Docker file, I keep it opened. Okay, so I am just keeping my Docker file opened, and I have some previously built iris app and I am deleting that. Okay, so for now I have opened this one, and let me go back to my VS Code. Okay, now what I am going to do, I am going to create my Docker file. So the file name will be Docker file. So you have to maintain the exact same name, guys. So make sure that you maintain this exact same Docker file. Okay, so now let me write some commands. First of all, I am going to write the command from Python colon 3.11 -lim. Okay, so what does this line mean? I am saying I want to create one Docker file where I am going to use Python 3.11 as my programming language. Okay. Then I am saying work directory, work dir, then /app. I am telling create a new work directory and give the name of the work directory is app. Great, no problem. Now once my directory is created, right, I need to install the dependencies like I did in my local system, right? So same flow that I did in my local system, I need to replicate that into the Docker steps. So I need to install the dependencies, right? Install Python dependencies. Okay. Now further what I need to do, simple command. First I need to copy the code, copy requirements.txt. Okay, and dot. What does this line mean? Simply it means that I am copying requirement.txt. From this path I am copying this requirement.txt. Then dot. Dot means what? In the same path. Okay, in the same path. So right now I am creating one new directory called app, right? Creating a new directory called app, right? Now inside this new directory called app, what I am saying, copy the requirement.txt in the same root path. Okay, I am saying that. Okay, after that I am telling run this command. Run, what to run? Pip install. You can see the command. No cache directory -r requirement.txt. Okay. So now what I am saying, copy all source code. Okay. So see guys, this is the work directory called app, and I am copying the requirement.txt. Let me just accept it. Yeah, I am copying the requirement.txt here in dot. That means it is not inside the app directory. Okay, it is inside the root directory of my Docker system. Now you can see copy all source code. You can see my AI have given me the output automatically. So what it is saying, copy main.py in the root path. Like the same here that is happening here. If you see, same thing is happening here. If you see, okay, what is happening? Simple now. See, in my code, if you see, my main.py is there in the root folder, right? In the root site. That's why I'm copying main.py in the root. Then my app code is inside the app folder. That's what I'm saying, copy the app folder into the app folder, no problem. Then I'm saying copy model inside the model folder. I'm saying copy static inside the static folder. Okay, no issues. Okay, and then what I'm saying, run the train command. So you know, right, inside the model, the train.py is the code which will be training the machine learning model, right? So what I need to do, I need to go back to my Docker file. Hold on. Yeah, and I need to run the command. Run Python model /train.py. So it is going to run the train.py command and expose 8000. So I am exposing my 8000 port, and I am simply saying run this command. Like I ran the command, right? I ran this command called uvcon main app port 8000, right? Same I am running. Execute this command uvcon main app host this port 8000. So it will be running the command inside port 8000. Okay. So yeah. So we are done. So we are done with our Docker file creation. So now what I do, simply I will create the Docker container, right? I mean not the container, sorry, create the Docker image first. Okay. So now further what I need to do, I need to run this command called docker build -t iris ml app dot. So if I execute this command, it dot means what? Dot means find the root part or the current path. If I enter, right, you will see something here. See, can you see? It's now creating the image. Now it happens so faster manner. Why? Because before I got this whole thing, right, I just did a small practice or small kind of demo so that I can show you the actual implementation so that we will not get any errors, right? That's why I just ran this code before this recording only. That's why it happened so fast, and it happened so fast because of the caching. And I'll discuss about caching and all later. But you can see exporting layer, exporting manifest and all. It just created the file, right? So if I go to the Docker, you will see it. Okay, I just come here. You'll see it here. You see your Iris ML app. Now you can see your image. Now let's create a container from it. Now to do that, run this command docker run -t just name iris app -p 8000 is the port, then iris ml app. Okay, I'm telling this. Okay, so we will more discuss about this port mapping and all, but for now this is the command that I'm executing. I'm telling my code or my app will run on 8000 port. I'm saying that. Okay, I just click on enter. You can see I got my code. That means my container is running in a detached mode. Okay, and you know how detached mode works already. So if I just go to the 8000 port now, see, just to show you, you can see in my my bad, hold on a sec, I'm in a wrong file. Just quickly, yeah, you can see in my code my app is not running through my code, right? The code is running through only Docker. And if I now go back to the Safari and refresh the screen now, see, it is coming. That means it is running. And if I show you in the Docker also, see, inside Docker, if you go to container, right, you can see Iris app. It is running through Iris ML app image. And now if I choose the values, I can choose the values like this. I choose values like this and click on the classify species. See, it is classifying it properly. See, it is classifying it properly. Oh, okay. So this is how you can Dockerize your whole project, and you can run through your own created custom image. Hope it helps, guys. Now we talk about Docker layers. So what are layers and why do they exist? We will talk about that. So what is a layer? If I really give you an idea about it. So every Docker image is not one big blob. It's a stack of read-only layers. Each instruction in a Docker file that modifies the file system, like run, copy, add, right? Like run command we use in our code, right? Copy command we used in our code, right? So creates a new layer on top. So these commands actually create some layers that don't change anything. env expose command, cmd command. So if you use these things, it will not make any changes inside layers. It will simply create a 0-byte metadata layers. The key inside is layers are cached and shared. If two images share the same base layer, Docker stores that layer exactly once on disk. This is what makes Docker fast. So I have told you, right? So because before your recording, right, I did my own implementation. Because of that Docker image creation was so fast since it was cached. Okay, but when I did it for the first time in my laptop, it was taking some seconds, right? So if I show you inside the code, okay, if I just come back to my code, if you see this line was getting executed, can you see cached mentioned here? It was cached. That's why it was not taking much time. Again, we will more deep dive about caching here, but just for your information. And can you see something called exporting layers? Can you see this is the layer ID SHA256 something. This is also the layer ID SHA256 something. So you can see these lines are getting executed one by one. So these are the layers that we talk. These are the layers that we talk whenever you execute your command. Like I executed this command, right? Docker build this command. So this command was exporting layers, was showing into the logs, correct? So it was going through the logs. And now I am going to show you the same thing through the visual so that you get it better. So if you see visual example, this is a visual example. If you see, I first ran this command, right, from Python 3.11 Slim. So this is layer 1, base OS plus Python runtime. So you know, right, Docker runs on some base OS. It has the base OS already, and I am choosing Python as a programming language. So Python will be the runtime here, and it has some ID like this. Then in layer 2 I ran this command called ran apt get install y gcc. Again, in our demonstration I did not run exactly the same command, but you just think it of. So run apt get install and it is installing something, right? This is in layer 2 and this is a waste packet, simple. Then in layer 3 what I did, copy requirement.txt dot. This is in layer 3. Then layer 4 run pip install something. This is layer 4. And the layer 5 I was copying the app folder, correct? So this all things are read only below, this all layers are read only. Okay, you can see container layer, writable, exist only while container runs. Since my container was running, I was able to see this all layers, and each line you can see from run copy. These commands, like I have explained here, you can see run copy add, this kind of commands always creates a new layer inside your Docker. Okay, that's why it was happening like that. Okay, I hope you have understood. Now next, the layer cache, how it works. So I am telling you cache. Let's understand how it works. So Docker processes each Docker file instruction top to bottom. Okay, top to bottom, like if you see in my Docker file code, I go back to my Docker file code. So it happens from top to bottom, from here till here. It happens top to bottom, right? For each instruction, it computes a cache key. Now you can see for the from, for the copy, for the run. So for these commands, it was creating layers, right? So that's why for each instruction, it computes a cache key. And what are those cache keys? .sh something, right? If I show you again here, so this is the cache key that they are talking about. Okay, so a hash of the instruction text plus the layer below it. If that exact key exists on disk, Docker reuses the cached layer instead of rerunning the instruction. Since I had the existed cached layer, that's why it was showing like this cached. Okay, this is called a cache hit. Cache invalidation rule. There's something called cache invalidation rule. You have to know that thing also. The moment any layer's cache is missed, every layer below it in the file is also rerun. Even if their instructions didn't change, this is the single most important rule when writing Docker files. You need to know that, guys. Every layer below it in the file is also rerun if any layer's cache is missed. This is the Docker rule, how it works. If I just show you with some visual, if you see, this is the first build. So right, you just did this from, then copy, then you ran the pip install, then you copied it, and then you ran this command. So this all things got cached, no problem. Now when we made some changes inside the app code, that means we made changes in the app folder, then this thing got cached, no issues. This thing also got cached. Why? Because file was unchanged. Now this thing also got cached because dependencies also were unchanged. But since we made changes inside the app folder, this thing will not cache it, because this thing will not be cached and this thing will be rerunning. And because of that, the next line cmd uvcon main :app, this layer will also be running. Since this layer is not getting cached, because of that, this layer will also be running. Okay, so you can see rebuild time for this one will take 0.1 second when your all things are cached. But since in this case you had one change inside your code, and because of that you are getting 0.3 seconds, because in this case two layers reran. Okay, great. Now another thing about layer ordering, the most practical skill. So the rule, put things that change least at the top, things that change most at the bottom. This maximizes cache hits on every rebuild. So this is a rule that you need to know when you write your Docker file code. Put things that change least at the top. So in your code, if there are few files, right, those has a very least chance of getting changed. Okay, so you need to put things that change least at the top. So those files which will not be changed so much, right, you have to keep them on the top, and things that change most at the bottom. That means if in your code the few files are getting changed every time and they are most likely to change, keep them on the bottom side of your code. So this will maximize your cache hits on every rebuild, because if you can use the cache thing properly, right, you can make your rebuild faster, right? That's how we are trying to know about the layer ordering. And I'll just show you some example. So this is the bad and this is the good thing. If you see, this is the bad pattern, this is the good pattern. So what is the problem in the bad part? If you see, first is from Python 3.11, no issues. Then what I'm doing, copying the code. But you know, right, inside my app folder I had some code for predictions, right? And that code is more likely to change in most of the cases. And then I'm calling work directory and then I'm doing the pip install requirement.txt. So requirement.txt is very less likely to change. But because I kept this line after the copy command, and this copy command will this copy command will always have one change, and because of this issue this entire thing will rerun. But if you see in this good thing, you can see what I did. I first copied the requirement.txt, okay, and I'm running the pip install command. So this entire thing from till the run pip install command, things will be cached. But if I really want to make any changes inside the app folder, let it happen. So because of that, only this two layer will be rerunning. But because of this mistake, the entire build will be rerunning, which will take more time. And you can see below as I have mentioned, with the bad pattern, every single code change triggers a full pip install, which can take 60 to 120 seconds. Because if your requirement.txt has a lot many dependencies, it will take a lot of time to getting installed. So with the good pattern, pip install only reruns when requirements.txt itself changes. That's why we focus on that. Okay. Next, layer size. What makes images fat? So each layer adds to the final image size. So you will have an image size, right? So you need to know how to fix them. So if I show you through some visual approach here, this is the first approach. You can see your from Debian Slim. Again, this is not Python example, but Debian is another kind of a system. Okay, for now you can think it of like that. So the base size of this layer is 80 MB, and then running this command and size is plus 120 MB stored in this layer. Then this line is also running, right? Run rm dash rf. What it is doing? It is simply removing something. Okay, files hidden still in layer above. Then my app code, and the image size is 200 plus MB because of these steps. And why? Because run apt-get this command, Docker commits a new layer with all the downloaded cache file baked in. Since it has downloaded all the cache files, it got almost 120 MB extra. Then running the rm command, Docker commits another layer that hides the file, but the previous layer still exists in image history. So this command has hide some files, but because I ran this command in the previous layer, right, still this thing will exist inside my memory. Okay, and because of that I'll get a higher size of image. But if you see in this approach B, I'm using a chained with double and. What I'm doing, I'm chaining these two commands together. First the Debian one, which includes 80 MB, then the simple run command, and here I'm using double and, which is called chain command. What is the thing is doing? You can see this command runs both commands inside a single layer. It's running both the commands inside a single layer, right? It's not running separately. That means this thing is inside one single layer only. And because of that, Docker only snapshots the file system after both commands finishes. By the time Docker takes this snapshot, the apt cache is already gone. Why it is already gone? Because this rm command is also getting run. Because of that. So it was never committed to any layer. Since it is never committed to any layer, that memory which it was taking extra will not be added inside your image. And because of this entire thing, you will have a lesser image size. You can see 95 MB.
Okay, so now we will discuss about the port binding. So what is a port binding? So again, first we will understand through some definitions, and then we will focus on the practical part, and there you will get the more idea about it. Okay, so what is a port binding? So a Docker container is an isolated environment. You know it, right? Docker container is very isolated environment. It has its own network stack, its own IP addresses, its own ports, completely separate from your host machine. It is completely separated from your host machine. It is not
connected with your host machine by default. Okay, so by default nothing from outside can reach it unless you are going to create a connection. Nothing from outside can reach it. Okay, so port binding is the bridge you explicitly draw between a port on the host machine. So port binding is the thing which is the bridge you explicitly draw between the port on the host machine and the port inside the container. So port binding is something very important inside Docker. So what is the syntax about it? So when we run some commands inside Docker, right, Docker run then dash p, right, that is the port binding that we do. Again, I will show you that. Even we did that in our previous section also. If you have seen that previous section, in the previous section when we ran that code, on that time also I used dash p, but on that time I did not explain it properly. Now I am explaining that thing properly. So dash p, then you pass a host port. Host means what? So right now in my case I will be running Docker desktop from my local system, from my MacBook. So right now this Mac is the host, okay, and container port will be the container that I will be creating or I will be having. Okay, so the left side is what you type in your browser. So I hope you can recall in the previous section when we created the Docker image and we created the container, and through localhost 8000 we just hit that API and we were using that Iris app, right? So this is the host port. So the port that we pass here, that port only we will use in our browser to access that. So the right side is what the app inside container is actually listening on. So you are hitting through the host port in your browser to connect. Now whatever things you are doing, right, it is getting connected with the container, right? Now container is listening through the container port and we are doing our job through the host port. I'll again show it to you now. Okay, so just for your visual understanding, you can see, so this is a host machine. Okay, so this entire thing is a host machine. Okay, and you know, right, in my case, in my Mac right now I'm using, and in my Mac I have my Docker desktop and my containers and all, everything inside my Docker desktop in my laptop, right? So this is the entire host machine. So inside the entire host machine I have my Docker container, correct? I have my Docker container. Now when I'm hitting through the HTTP request localhost 8080, let's say, through my browser, right, then what is happening? Whenever I'm hitting localhost 8080 from my browser, it is actually going through the host port 8080. That's great. Now what port mapping we did? We did the port mapping called dash p 8080:8000. Now this 8080 is the host port, and that's how we are accessing through localhost, and this 8000 is the container port, and this is the container port. You can see 8000, and I know my fast API app, that Iris app I built or the Flask app I built, whatever I built, this is that one. It is running inside my Docker container, and this is the app, and it is running on the 8000 port inside Docker container. It is the container port, and I am accessing it through 8080 port in the browser. So this 8080 is actually connecting with this 8000 port, and this is how they are listening. And how and who decided that thing? We as a developer decided that thing, that okay, c dash p 8080 will be my host port and 8000 will be my container port. I hope you are getting that thing. Okay, now there are some commands. You can see docker run dash p host port colon container port, then the image name. So there are few commands, and I'll show you by executing each and every command just to let you feel that it is working. So like you can see, docker run dash p 8080:8000 Iris ML app. So if I just go back to my Docker quickly, you can see I have the image called Iris ML app already that I created before, and it is right now inside image, but in container I have nothing right now, and I'll execute the command, right? I'll execute the command docker run dash p 8080:8000. So in this case, the first one is the host port. That means I will access my app through localhost 8080, and container port is 8000, which Docker will be listening on. Okay, so host will be 8080 and container will be 8000. I'll just show you that. I just go to my VS Code. I'll run this code docker run dash p 8080:8000, then iris ml app. See, it is showing up, right? And now why it is showing up like that? Because last time I used dash d, and dash d means detach mode, and right now it is not in detach mode. If you see, this thing is not in detach mode right now. Okay, this thing is not in detach mode right now. Okay, so that is why it is looking like that. Okay, but if you want to run through detach mode, it will not show logs in the terminal. It will just run behind the scene. Since I have not used dash d, that's why we are getting this logs. Okay, and that means if I close the VS Code now, my app will not work. But if I use dash d, then it will be detach mode. That's why I will not see the logs inside the terminal. So even if I close my VS Code, that app will still run. Okay, so if I go to the browser, or if I just go and open Safari. Okay, if I open the Safari in my laptop, yeah, I have opened my Safari in my laptop. If I say localhost 8080, if I do this search and execute the code, see, my app is running on localhost 8080. If I want, I can give values like this and I just execute. So I'm getting the output. See, this localhost 8080, this is the host port, and this 8080 is connecting with the 8000, which is the container port. Okay, likewise, if I try this one now, docker run dash p 80:8000, let's say. Okay, now I just close it. Can you see the logs is also coming in this case? Because I am not using this dash d, that means detach mode. That's why I am getting logs here. Okay, I just close it. I run the same command. I just make it 80. Just make it 80. Execute. See, same thing is coming up. And now if I go back to my Safari and just hit through 80, see, I am still be able to access it. And if I go inside Docker container, just to show you, if you see the container section, so you can see, can you see two things here coming up? One coming up like Docker wonderful roads, and another come happy Bartik something. Now can you see this 8081 is actually stopped, but the 81 is running. If you see, I can stop it if I want to. That's why you can see this 8001 is stopped and this 80 is running. That's why through 80 I am able to access it. Localhost 80, I am able to access it. If I want, I can pass value and I am getting the answer. Likewise, if I show you localhost 3000:3000, okay, let's say, okay, I just close this one also. So let's do like this, 3000:8000. Also with this example, 3000:8000. Now if I do it like 3000, see, it is still coming, and if I click on this, I am getting the answer. So because of this, it is working. Okay, now if you really want to bind to specific host IP, you can pass localhost ID like this also if you want to. Okay, okay, I hope you have understood how to pass the host port and the container port. I know this part is clear now. Next, what happens without p dash p? If I don't pass dash p, what will happen? So this is a critical concept to drive home. Running a container without dash p means the app is running but completely unreachable from outside. So your app will be running, no issues. But since you are not saying which port to listening to, which port to connect, right? That's why it will be unreachable. So expose in a Docker file is purely documentation. If you see, if I just show you, if you just open the Docker file, you think something called expose 8000. You can say that, okay, I have provided expose 8000 here, then why it is still not be able to connect it? Because expose means what you need to understand. Expose in a Docker file is purely documentation. It is just for documentation. It does not bind anything. It tells other developers this container listens on this port. it is technically not doing anything. It's just for the documentation, so that a developer understands that okay, my thing is running on 8000 port, but this container listens on the port, but it does not bind anything. But nothing works until you use -p at runtime. So if you do not use -p, then it will not work. You cannot reach your app. Next, multiple port mapping. So one container can expose several ports at once. Like we were passing only one port, right? We were passing only one port, your what do I say? One port for host port and container port. But if you want, you can have one container can expose several ports at once. Common with apps have both at HTTP API and separate metrics on debug endpoint. If you have two endpoints, right, you can use such cases. So I just show you by running this command docker run -t -p. Okay, I'll just quickly execute the command. I'll just stop this one. I'll show you how multiple port binding works. Docker run -p. Let's say 8080:8000 -p. Let's say 3000:8000, or maybe 3000:3000. Let's say that's just name iris app new and iris ml app. So here I am passing my container name iris app new, and this is the image name, and here I am passing multiple ports. If you see, this is the host port, this is the container port, this is the host port, this is the container port. Okay, and if I execute this code, see, it's running fine. If I now go back and try to execute or try to access my app through 8080 port as well as through 3000 port. Okay, so if I just try to execute through 8080 port first, 8080, and instead of showing into okay, let it be, and if I try to access 3000 port, does it work? I am able to access it. But if I show you here, can you see show two ports? See, it is showing up what? It is showing up my thing is running on 8080 as well as this 3000 port. So if I quickly show you in the browser also, like this is my browser, right? So if I quickly just open my incognito window and show you the same localhost 8080, you can see I am able to access it also through my incognito mode. And now if I try 3000 port, I am not able to access it, but I was able to access inside Safari. Why? Because Safari was caching my browser. Safari was crashing my browser. That's why. Because I wanted to show you this error, I was not getting inside Safari, and I understood why. Because Safari was caching my app. Because of that I was getting. But can you see I am getting 3000 error? And why so? Why is the error? If you are clever, you might have seen that. If I just stop the app, if I show you, okay, in this case I provided docker run -p 8080:8000, good, -p 3000:3000. Now we know. So what is the container port that we have given for our app? 8000. This is my container port that I have already given, correct? Since this is the container port that I have already given, now in this command that I am executing, here I am seeing multiple port binding we can do. I am doing multiple port binding only. 88 is the host, then 8000 is the container, good. Now 3000 is the host, 3000 is the container. But do I have anything called 3000 in my container? No, right? I have 8000. That's why I am not able to access my app to 3000. Not able to access the app to 3000. What I need to do? I need to just change it. I need to make it 8000. If I make it 8000 and change the name of my container, since I have created a container already with this name, it may throw an error because it will find that same container already exists. So I just create a new name called new one and execute. So it is running now, and if I go back to my thing now and if I execute, see, now I am able to execute, and now I am able to access localhost 3000. I am able to access. Even now I can access it through 8080 port 2. 8080. still able to access it. So I hope this concept is clear. So hope you have understood this section now. Now if you see, same thing I am showing up here with the visualization. You can see 88 is the host port, it is connecting with 80 web app. You can see 1990 host port connecting with 1990 endpoint. Okay, again 5433 host port connecting with 5432. So let's say if you have 3 containers like this, one container is listening to 80 port, one container is listening to 1990 port, and one container listening to 5432. Listen to my words, I am saying container port. This web app is another Docker container and it listens to 80 port. 80 port is container port, and for this matrix endpoint also 1990 is the container port. For Postgres DB 5432 is the container port. Now what I did, I ran like I showed you two types of, using 2 ports I have showed you port binding. If you want you can do for 3, 4 also. So you can see host port 8080. So 88 is the host port now, which will be connecting to 80 container port. 1990 host port, which will be connecting to container 1990 port. 5433 is the host port, which will be connecting to 5432 container port. Okay, I hope this is clear now. Now another thing, running multiple container on same host. So I have already showed you this example only, running multiple container on same host. That example only I have showed you. This is where port binding gets interesting and where students always hit their first conflict. 2 containers cannot share the same host port, but they can both expose the same container port mapped to different host ports. That's what I have already showed you. I showed you how you can use 8080 as well as 3000 host port, which can connect to 8000 container port, right? And this is the example that I have already showed you. And this is the simple visual example. You can see you have host port 8001, you have host port 8002. And what is doing? It is connecting with one simple 8000 container port. These two are connecting with this port only. Okay. And you can see V2. VT is also connecting with this 8000 port only, which is the container B. Okay. If it can happen that multiple host port can connect with a single container port. You can see this is the correct approach of writing that code, and I have already showed you that thing, right? Great. Now we will talk about Docker network.
Okay, so now we will understand about Docker network. So Docker networking is the system that controls how containers communicate with each other, with your machine and with the outside internet. So as we know, all the containers are isolated from each other. So even if you do not create any network, or if you do not create a way to communicate with it, by default it will not communicate. Even it will not communicate with the host machine also, and you know it already, that I have already discussed few seconds ago, correct? Now network is something that will help you to communicate with the containers. It can happen through your host to container, multiple containers and all, right? So by default every container is completely isolated, as I have already discussed. It has its own network, its own IP address, and no way to talk to anything unless you explicitly allow it. Okay, Docker networking is how you define those rules, how they will communicate and all you decide through the Docker network. And in simple terms, Docker networking decides who can talk to whom, how they find each other, and what traffic is allowed or out, in or out. Okay, so how Docker creates network from container. Again I will show you through the practical. Okay, but let us first understand how Docker creates a network from the container. Okay, so there are few components that we need to understand. Again, you don't have to deep dive on these components, but just to let you know the terms, let you know the words, so that you understand their use case. Okay, so I believe no one even discussing this much in depth on YouTube channels. Like if you have seen multiple YouTube videos on Docker,
They have discussed the basics, how you can create a container, how you can create image, and that's it. And they have built a basic Node app or Python app, and that's all they show. They will not discuss much about network. They will not discuss much about volume, security, that we will discuss next, right? So I believe that this course is very in depth for everyone, whoever is learning about Docker. Okay, so let's come back to the topic. So the first component is network namespace. So every container gets its own isolated network space. So the Iris ML app we created, right? It was an image, and if I just open the Docker and if I just show you, so these all containers we have created so far, right? And you can see every container gets its own isolated network space, its own IP, its own routing rules, its own firewall. So like this, for each and every container they gets all this. Okay, it's completely separate from a machine's network. Okay, so this is the namespace that we need to know. Then virtual cable or a VETH peer. So Docker creates a virtual Ethernet cable. Again, it is not a physical cable, it is a virtual Ethernet cable. One end goes inside the container called ETH0. One goes inside the container and the other end connects to a virtual switch on your machine. Okay. Then virtual switch. What that virtual switch is that we have mentioned now. So the virtual switch called Docker 0 by default connects all containers together on the same machine, just like a physical network switch connects computers. So the virtual switch by default named as Docker 0, it connects all containers together on the same machine, just like a physical network switch connects the computers. Okay. IP address, as I said, each container has its own IP, right? So Docker automatically assigns each network a private IP like this one. Again, this is not the exact one, but this is like that. This IP only exists inside Docker's private network. The internet cannot reach it directly because it is isolated. Then NAT or network address translation. So when the container want to reach the internet, Docker replaces the container's private IP with a machine's real IP, right? I hope you can recall the port binding thing, right? It's kind of that way. Okay, Docker replaces the container's private IP with the machine's real IP. Okay, like a company using one public phone a number for all employees. It's like that. Okay, so again, you don't have to deep dive about these topics, because if you really deep dive about Docker, you will get thousands things to know, and you really no need to know thousand things if you are a developer. If you just know this much, it's fine. Okay, so now there are multiple Docker network drivers available. Okay, so like breach, custom breach, none, overlay, MacVillain, host, and we will discuss about each of them in detail with the implementation part. Okay, so first let's discuss why does it matter. I mean, why we are discussing so many things about Docker network, why there are so many components I need to know, why I need to know about the breach network driver, why I need to know about custom network driver, or why I need to know about host, none, why I need to know these many things, right? So if I explain, so imagine you have two containers. Okay, you have two containers. One is your web app, as you can see in this screen, and another is your database. Okay, and by default they cannot see each other, right? By default they cannot see each other. So Docker puts every container in its own bubble, right? And to let them talk, you need networking. Just to let them talk, you need networking. Simple. And if you really want to do something, let's say, like we have built this Iris app, right? Iris ML app, and you can see multiple containers are created around it. Now let's say you have one Iris ML app and you have another called Postgres, which is a database. Okay, and you want to connect this Iris ML app with that Postgres team, which is there inside the Docker container. Right now we don't have Postgres in our implementation, but let's say you have that. So if you have a scenario like that, then you need to use network to let them connect, let them talk. Okay, and you may have a question. So far the things we did, we haven't seen networking there. And how we were doing this many things, how we were communicating through a local host, how we were doing multiple port binding and blah 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 things. I will just explain why I was not discussing about Docker networking or how it was happening before coming to this point. I'll discuss. Okay. So the first thing that I discussed, first network driver that I discussed, that is about bridge network. And here I'll explain what is it, how it works, and when to use it. So first of all, what is it? So this is the default network driver in Docker. So read this line, guys. This is the default network driver in Docker. Docker creates the virtual switch. Again, that's why I have taught you this components, because these terms, now you know what does it mean a virtual switch. So now you will be able to understand it properly. So Docker creates a virtual switch called Docker 0 on your machine. So now you can recall, right? If I just go back to that section, what is the virtual switch? The virtual switch called Docker 0 by default connects all containers together on the same machine. So this virtual cable, you can see, right? One end goes inside Docker container and another end connects to the virtual switch. So now one side is connecting with the container and another side is connected with your machine, and this is happening through this virtual switch. This is happening through the virtual switch. Okay, great. Now if I come back again, the same example, yeah. So every container automatically connects to it. Each container gets a private IP like this. Containers are hidden from the outside world by default, and by default network driver in Docker. So bridge network is a default driver in Docker. Even if you are not creating the network by your hands, whenever you are creating the container, when you are let them communicate with each other, right? It was happening by default through this bridge network driver. Though you did not know, because we did not discuss about this concept, but by default bridge network was there, and because of that reason only you were able to do all this kind of communication by default. Okay, so no name based DNS, containers find each other by IP only. So if you use bridge network, right, they can only find each other through their own private IPs, since it doesn't support DNS thing. Okay, now how it works, so Docker creates a VTH pair, virtual cable per container. One end goes inside the container ETH0, you know it now, and other end connects to the Docker 0 bridge on the host. So you have Docker 0 in your laptop, since my laptop is the host. So that end connects with this laptop. Outbound traffic is NAT. Container IP is replaced with your machine's IP. As I have already discussed, NAT is the one which does this thing. It replaces the container's IP with my machine IP whenever it is trying to communicate with the outbound traffic. You use -p8080:80, like this 8080 is the host port and 80 is the container port, to punch a hole host port and container port, right? IP tables rules handle all forwarding and NAT automatically. Okay, now when to use it? So if you really want to do a quick local testing with a single container, just use bridge network. And anyways, by default bridge network only works, so you don't have to much think about it. Okay, simple apps that don't need containers to find each other by name. Since we have built Iris ML app, which was a single container and it was doing everything in itself only, so we were not in a stage where we need to let it communicate with other container, right? So in that cases bridge network is pretty suitable. When you just need internet access from the inside the container, then default use it when you haven't thought about networking yet. So again, even though we were implementing that, we didn't know that networking is happening, right? So it is anyways by default. And then whenever you don't have to think about networking so much, you don't have to make your things this much communicated. So such cases, I believe this kind of networking makes more sense. Okay, now one caution: this is not for multi-container apps. Use custom bridge instead. So multi-container apps means what? It means when your app or your container needs to communicate with other containers. Such cases bridge network is not recommended. Why not recommended? Because the first reason is it doesn't support DNS. So if your container needs to find another container, it has to do it through IPs, but it's not a efficient way of doing it. Okay, that's why we have something called custom bridge, and we discuss about that. Okay, so I'm not going to show you the practical of this one. Why? Because if I come to my VS Code, if I just close this one If I just quickly run the same command, this is the command that we ran last time, right? And I am not mentioning anything related to breach network in this code, right? Correct? But by default it is using breach network, and that's why I'm not showing the practical example of this one, at least because you know it now very well. Okay, now let's go back to my thing. Yeah, now let's talk about custom breach network. Again, same way, what is it? The a breach network you can create with a custom name. Again, custom breach is not that fancy thing, it is just a bit customization of breach network. So as I said, when I was executing the docker run command, it was creating the breach network by itself. Now you can create your own breach container, or sorry, own breach network. You create with a custom name. You can give a new name, and that is called custom breach network. Works the same as the default breach plus built-in DNS. Now it has DNS. Okay, containers resolve each other by container name, not IP needed. So whatever container name you can give, you can communicate through that. You don't have to use IPs. And each custom network is completely isolated from each other, and we know that already. Docker Compose creates one automatically for your project. So what is Docker Compose? We discuss later on. Okay, but for now we don't have to think. But Docker Compose is something like we were running so many commands to do something, right? We were running multiple commands. We are creating network, we are creating containers, we are creating images. There are a lot of things we were doing, so we can reduce that step with a single lines of code, and that is called Docker Compose, and we will discuss about it later. But right now just think this much about Docker Compose. Okay, now most important network type for real applications. So custom bridge network is like most important network that you need to know while building anything related to Docker. Now how it works? So it creates its own Linux bridge separate from Docker 0. Docker starts a DNS server at this port inside each container. When an app says connect to DB, and what does it mean a connect to DB? That means your app is running on one container and it tries to connect with DB or database which is in another container. So Docker DNS returns the DB's IP automatically. Right now you can hot connect or disconnect running containers anytime if you want to. Okay, containers on different custom networks cannot reach each other. So containers on different custom network cannot reach each other. You have to make sure that your containers should be under the same network, then only they can communicate. Docker Compose wears all the services on one shared custom network. So Docker Compose does it very easily, and we will discuss about that. Then when to use it? Any app with more than one container. If you have a scenario when you have more than one container, just use it. When containers needs to call each other by service name. Simple thing. Docker Compose I will not discuss now. When you want isolation between different app stack. What does that mean? Let's say you have multiple app stacks, right? And each apps are very different than each other. Then for each app stack or for your each project, you can create a separate custom bridge network so that they will not create a conflict between each other. Okay, so production microservices running on a single host. So such cases you can use it. Default choice for all multi-container setup. So mostly custom bridge network you will use to do this thing. Okay. Now let's see the practical of it. So as I have already said that whatever commands you execute, this all happens by default whenever I execute in Docker command in bridge network. But when it's about custom bridge network, as I have said, you can create your own bridge network with your custom name. Now the command is for that Docker network create my app network. This is the simplest command you need to execute to create your own custom bridge network. Docker network create my app network. So my app network is the name of my custom bridge network. Okay, the press enter and it is done. You can see it is created that. So if I want to run, I can run the same command like I just ran. Just I need to add simple thing, that is I just need to add, maybe I just try to add, let's see, yeah, dash network my app network. work. Enter. I'm getting an error. See, it is giving me an error that container already exists. So what I do, I just rename this name of my container. See, now it will run. See, now it is running. And if I just quickly go in my Safari, if I have it opened, yes. And if I try to execute through, let me show you through my browser, I believe, because this Safari is caching to everything now, so it's been an issue. So if I try to execute localhost maybe 3000, see, I'm able to access it. If I try localhost 8080, still I'll be able to access it. And this is happening through the simple. This is happening through the custom bridge network. Okay. I hope you have understood it. Okay. Great. So this is all about it. Okay. Now let's discuss about host network. What is a host network? So in host network, container has no separate network on its own. So when it's about host network, container has no separate network on its own. It directly uses the host machine's network stack. So it doesn't create any network, it uses my laptop's network stack. Port 80 is in container, port 80 on your machine, same thing. Okay. No IP translation. P flag ignored entirely. Containers is all host interfaces like this. How it works? Docker skips creating a network namespace for the container. When it's about host network, it skips creating network namespace for the container. No virtual cable is created. Okay. And containers process binds directly to the host real NIC. No IP tables rules added for this network. Zero overhead, packets go in and out as if from the host itself. Okay. Only fully works on Linux, no effect on Mac and Windows. So right now I am using my MacBook, right? So it will not work on my laptop. Why? Because it fully works on Linux. It doesn't work on Mac or Windows. That's why even if I can show you the commands, even if I execute the command, you cannot see the app in my laptop running because it fully works on Linux. That's why. Okay, and you can read out the use when you want to use it. I just discussed this one. Linux fully not for apps needing isolation. On container per port, no two apps on same port. If you want to do these things right, it cannot be possible inside host network. Okay. Now, if I just want to show you the practical example, nothing much you need to do. Just go back to the code, stop this thing, just try to execute the dash network and just call it like host. You just have to call it like this, and if you execute the command, it will work, but you cannot access my app through this. If I try now to just show you, just quickly delete and execute. Okay, you can see. Okay, I am getting again the conflict. Just create a new name. See, it's running and it's saying what? Published ports are discarded when using host network mode. Since I am telling this dash p, right, it is ignoring that. That's why it is telling published ports are discarded. So if I try to execute, I try to check now. If I try to check through my incognito localhost 8000, it will not work. If you see, it will not work. It doesn't support that. Okay, I believe you have understood it now. Okay, so now let's discuss why host network cannot be accessed from browser. So this is my Mac or Windows system. Docker desktop on Mac or Windows runs Linux in a hidden virtual machine. You need to keep that thing in mind. That Docker desktop running in my MacBook right now, it runs on Linux in a hidden VM. You never see this VM. Your containers live inside it, and that is why this Mac is actually communicating with this hidden Linux virtual machine, and that is communicating through the container. And you can see, right, dash network host. When I passed inside the container command, it makes the container share the VM's network, not your actual Mac and Windows network. So this is giving this one. So even if it works perfectly inside the virtual machine, that means inside this one, but you still can't reach it from your browser on Mac or Windows. So if you want to test it, I would suggest that you can run one Ubuntu server or Ubuntu image in any EC2 instance or any server on AWS or Google Cloud, and then you can test it. It will work there. Again, in our playlist, AWS will come later on, but if you want to test it, you can do that. But mostly I don't think you need to test it now. It's like just to let you know these things exist. Okay. Now let's talk about none network. None means what? So what is none network? So container has absolutely zero network access. Zero network access. No one can access it. Cannot reach internet, cannot reach any other container. It cannot reach anything. Cannot receive any incoming connection. Only loopback interface localhost exists inside. Data can still be shared via volumes. No network needed for that. So when it's about, you do not want any network access, because by default it has breach network. But if you want that, I do not want to give it any kind of access, just use non-network. How it works? Simple. Docker creates a network namespace but puts nothing in it. Only loopback interface is configured. No VTHP, no breach, no routes, nothing. Any network call to an external addresses fail immediately. No one can access it. But file system, CPU, RAM, all will work perfectly fine as normal, because it is a container. It will have its own file system, own CPU, own RAM. Those will work, no problem. But that container will not be able to access the internet. It will not be able to reach by anyone. So think of its running the network process in a total network blackout. It's running, but no one can access it. And when to use it? So running untrusted or third-party code safely. So when you want to run any code that is very vulnerable or third-party code, you are not sure about the code's security, just run it. Since that container doesn't have any connection, so it will not create any impact. So bad jobs that only need to read and write files. Like later on we talk about Docker volumes, right? So there you will get more idea about volumes, but you can think volumes like a storage inside Docker containers. Okay, so if you have something like that you want to do some read and write operation in your container, and for that you do not need to connect with any network, so such cases you can use non-network. Then generating cryptographic keys and all, you can use it. So use when data must never leave by a network. So if you have too much sensitive data and you do not want to let run through the network, just use it. Okay, and how to mention that? Nothing now. If I just show you, same thing, same like host. I was calling here network host. Now what I need to do, you need to just call a network, then none. Again I am getting error. I just make it the new name. Yeah, this is also non-network example. I hope it is clear. Next, overlay network. Okay, so overlay is nothing but, so overlay spans multiple Docker hosts. When you have multiple Docker hosts, you can use overlay, and then containers on different machines act like they are on the same LAN. Okay, and each container still gets a private IP like it used to get before. DNS works by service name, as we know. It supports load balancing via virtual IP. Okay, so load balancing via virtual IP means what? You have one IP but many replicas. What does it mean, load balancing here? That means, let's say you are getting, like, your app is built through Docker and you are getting millions of customers hitting your Docker container. In this case, your Docker, because of your RAM issue or your CPU issue inside your Docker container, it may fail or it may die. Because of that, we create single IP, but we create multiple replicas of it, so that one thing doesn't get the impact. That impact should be spread out through multiple replicas so that it can balance the load. Okay, and what is used? It uses VXLAN that wraps the network, wraps the container packets inside UDP and sends to other host. And this is a bit technical thing, like a bit more technical. Like you can see, I am discussing about Docker Swarm and all. Again, you can read it out. Docker Swarm and all we are not discussing in this course, but we will discuss later on in this playlist only. That's why I'm not discussing much about this overlay network. Just for information, when you have more setup needed than single host network, when you need multiple hosts, when you need high availability, if one server does, other should keep running, microservices spread across a cluster. If you have a scenarios like that, I mean, when you have a pretty big scenario, when you are thinking about scaling your Docker container. Such cases overlay network come into the picture. Again, we will discuss about more about overlay network later on, but for now if you know that much will be fine. Okay. Last one is the Magvalon network. Okay. Again, this is also a bit technical. Okay. So I will not discuss much about it, but give you a very basic idea. Okay. So containers gets a real IP address on your physical LAN. Routers and switches see it as an actual machine. No NAT container is directly reachable from any LAN device. Magvalon container gets its own unique MAC address. IV LAN container shares host MAC but has its own IP. So it is more secure kind of a thing. Okay. So Docker assigns container a LAN IP. Traffic goes indirectly through the host physical NIC, and Magvalon requires the host NIC to be in promiscuous mode. Okay, no NAT, no virtual bridges, no IP tables translation. Okay, host cannot talk to its own Magvalon containers by default. So Magvalon needs promiscuous mode blocked by most cloud providers. Okay, use IBLAN when AWS and GCP as well instead of Magvalon. So you can use AWS or GCP mostly on Magvalon. Okay, so I know I have not discussed much about the Magvalon network because, to be honest, this is very less likely that you will use. So that is why I am not much discussing about the network, but we will discuss about this network in detail later on when we discuss about overlay network. With that, we will deep dive on this Magvalon network also. Okay. So now we talk about Docker volume, and Docker volume is simple. Your Docker container will get us a place to store its information. Okay, that means Docker volume. So here is something that surprises everyone when they first use Docker. If you run a database container, add 1000 rows and then stop and delete that container, all 1000 rows are gone forever. Since you have not created any separate volume that will retain the data, and because of that you created a database container, you added 1000 rows, but since you did not create a separate volume, I mean by default it has volume, then only it is storing their data, right? But since that volume is inside that container only, and because of that you stopped it and you deleted it, that means that Docker container gone, that data gone, that volume gone. This is not a bug, it's intentional. Docker containers are designed to be throwaway and reproducible. You can delete one and spin up an identical replacement in seconds, but that only works if nothing important is stored inside the container itself. So we need to understand about volume. Because of that, there are three types of volume that exist inside Docker: named volume, bind mount, and TMPFS. So if you use named volume, right, so Docker picks the location by default. It picks some location by default and it stores the data there. Survives container delete? Yes, even if you delete the container, since it picks some location, right, that's why it is retaining the data. Okay, and you can use it when you are working on production based projects. Bind mount, you pick the exact folder. Now you can pick your own folder where you want to store your data. It doesn't do it by itself. And yes, since you are choosing your own folder, and because of that it survives the deletion storage. Okay, and it is best for development. When your code is live, it's best for that purposes. Then TMPFS. So TMPFS stores the data on RAM only, never on disk. It's not storing anywhere, it's storing inside the container only, inside the container RAM only, right? That's why whenever you delete the container, it deletes the storage itself. So gone when stopped. So when you want to store secret, when you want to store sessions, when you want to store cache, right, in such cases you can use volumes. Okay, now let's talk about named volume in a more detailed manner. So you give the volume a name. Docker decides where to store it on your machine. So you just have to give a name and it will store it in your laptop. You don't need to know or care about the exact path, it will do it by itself. Okay, so multiple containers can read and write the same named volume at same time. So let's say I have created one volume and multiple containers can access it, no problem. This is how you share data between containers without any networking. So now, so for this volume thing, right, you do not need networking to do that. It can do it automatically. You just have to set it up, nothing much. Okay, and if I just show you that, through the implementation part, okay, I just quickly stop this thing which is running right now. Okay, and now to create your named volume, you need to execute this command called docker volume create docker volume create pg data. Docker volume create pg data. So pg data is the volume that you are creating here. Okay, I just press enter and you can see pg data volume is created. Okay, and if I now run one command, okay, if I run one command now, let's say again I'm not going to use the iris mlop now, I'll use something else. So I run a command which will run on PostgreSQL container. Okay, I just run a command which will run a PostgreSQL container. Okay, and I'll show you how I can add the volume with it, and then I'll show you also that if I delete that container but still that volume persists. Okay, so if I run this command docker run, I am running in detached mode -d. Okay, then dash name, let's say my db. I'm giving a name of my container, then dash v. Now dash v means volume. So which volume I want to give? I want to give the volume let's say pg data. I created pg data volume, right? And I mean, what kind of data pg data will store, right? I have to give the path. What kind of path? So inside your Postgres, there is a specific path where you store the data, and I am passing that path here. So /var var /lib /postgres, okay, PostgreSQL, okay, then data \. So you can see, right, I am saying you store all the information inside pg data from this path inside my container. Okay, because this container contains my data, that's why. Then -e. What is -e? That -e means what? It means environment variable. So let's say you need some environment variable that are things that you need to execute your PostgreSQL. Because see, you are creating your PostgreSQL container, it is a database, right? So it needs some credentials to connect with it, right? And these credentials are the secrets, and you cannot keep these secrets in your laptop in anywhere, right? So that is why when you are executing this command, on that time only you are passing those environment variable or the secrets here. So I am passing that secret on here, Postgres password equal to, let's say, secret. This is the password. Then \. Then I'm just passing the name of the image, Postgres:15. So this Postgres:15 is the name of the image that is there inside Docker Hub. It is now not pulling it from my laptop. In my laptop I have only iris mlop. Now Postgres:15, it is an official Docker image, exists inside Docker Hub, and anyone can push it. And if I press enter, you will see it is saying unable to find image locally. It is not able to find the Postgres image inside my laptop, and that is why it is now pulling it from the Docker Hub, and you can see it doing that. See, it is downloading that thing now in my laptop, and like this it will keep on downloading and it will execute everything in my laptop. And you can see downloaded the newer image, this one, and it is running. Since I ran this on detached mode -t, that is why you can see it is showing up this ID. That means it is running. Okay, so now let's say it's running, that's fine, no issues. If I show you that also inside my Docker, you can see Postgres is there now, and if I see the container, see my DB is running, it is a Postgres. Okay, great. So now let's say stop the container and delete it. Docker stop my DB, and I am using chain command that I already discussed before. Docker rm my DB. Here press enter. So what it has done, it has stopped my container and deleted my container. If I just show you, see, I don't have the container here. But does that mean it has deleted my volume also? Let's say docker volume ls. So can you see the, you can see if you execute this command, right, it will show you all volumes that it has created. Docker volume ls command, if you execute, it will show you all volumes that it has created in my laptop. So since I am using docker for a long time, and that is why you are able to see multiple docker volumes. But let's not focus on that. Let's focus on our own volume that we created just few seconds ago. That is the pg data. Can you see pg data is still there, that volume is still there. And now I can see where this volume stored in my local system. I can execute docker volume inspect pg data. It is telling me it is stored inside this part, this path. It is just telling me that why it is stored, what is the driver, what is the label, what is the name, what is the option, what is the scope. Everything it will give it to you. Okay. And if you want, you can delete this volume too. And now, just for your information, now this volume you can use with multiple containers also if you want to. Now, likewise, same, you need to execute the same command. You need to execute the same command and just add -v and then add this one. That's all only you need to do to connect your volume with multiple containers. Okay, I just quickly cleared this one. Okay, let's go back to a slide. Now let's talk about bind mount. So bind mount, in one sentence, you point Docker at a specific folder on your machine. Container sees that exact folder as if it's inside the container. Any changes on either side appear instantly on both the side. Okay. Bind mount is simple, guys. It's not that complicated. It's simple. It just, you have to mention the folder path, your laptop's local folder path. Like, I'll just show you that. If I just quickly open terminal, or I guess my terminal is open already. So I was just checking on it. I'll just quickly show you. You can see I'm calling a command called docker run -d dash mount. Now this is the bind mount that I'm doing. Okay, just hold on a sec. I just quickly, yeah, my bad, I was showing you the wrong one. Okay, yeah. So docker run -v, docker run, you know, -v means what? You know, v means volume, and you know it is bind mount. That means you can mention your laptop's folder path. So this $pwd means what? Pwd means present working directory. So right now my terminal opened in some specific folder, right? So this $pwd takes that only. Okay, and then I'm saying -d, then name, I'm running the iris app. Okay, now I'm just changing the name of the app so that it will not crash. App 2026 on the port 8000 iris ML app. Okay, if I execute the code, you can see it will be running. And if I check ls, -l, you can see multiple things in my laptop. And this is where, in this path only, it has created a folder where it is actually storing my data. I think folder you cannot see right now, but it is now going to store all the information. It is now going to store all the information in this path only. It is now going to store all this information in this present working directory. It's going to store everything here. Okay, so whatever will happen inside the app, it will store all those information inside this path only. That means inside this present working directory. Okay, great. And the next part and the final part, tmpfs. In one sentence, data lives only in your machine's RAM. It never returns to disk. It blindingly fast, and it completely disappears when the container stops. Simple. And this is simple command for that, which I was showing you wrong. So docker run -d dash mount, type tmpfs. Now when I'm executing this command and target, I'm saying /tmp. That means temporary. Okay. So if I just show you with some more example, or if I want to show you, yeah, okay, I just show you this example only. So this means tmpfs, that means store everything inside Docker's RAM. Do not store anything in your disk or in my laptop. And I'm saying target is /tmp, so inside temporary folder whatever things are there, you store it in your RAM, and make sure that your storage size should be in 256 MB. So I'm telling that I can mention the storage size also, that okay, you store data till 256 MB. I'm mentioning that also here. If you want, you can mention that also. And then I'm running simple my Iris ML app. No problem. Simple Iris ML app, and you know the Iris ML app now. So this is what it is telling. Okay. I hope this part is also clear. And volume part is so easy, guys. And now we'll talk about Docker Compose. That thing we were discussing inside our Docker network. So what is Docker Compose? So every Docker concept you have learned so far: port binding, network, volume, layers, and so many things requires separate Docker run, Docker network create, Docker volume create commands. We were running those commands one by one and to create multiple components of it. Now for the Iris app, just getting it running requires 4 to 5 commands, and you have to remember the exact flags and order every time. If someone else clones your repo, they have to figure all of that out from scratch, which is not a easy deal at all. So Docker Compose solves that problem with a single YML file like Docker Compose.yml that declares your entire environment, every service, every port binding, every network, every volume, everything. It depends inside the single YML file. Okay, what does it mean YML? Yet another markup language. YML means yet another markup language. One file replaces all those commands, so you don't have to write commands line by line. Instead, create one single YML file and it will do everything for you. One command, Docker Compose up, starts everything in the right order. It will create the container, it will create the volume, it will create the network, it will does everything automatically for you. Okay, now if I just show you that, first let me show you that Docker Compose YML file for your idea. See, so here I have to mention the version. You can mention anything if you want to. Then the services, what service I want. So I'm telling I want the service name called Iris app, and you need to maintain this indentation, guys. You need to maintain this kind of indentation. Okay, so services I am mentioning Iris app. What I want to build, I want to build the context is dot. Dot means what? Since you know, right, I was running the command called docker build -t dot. Dot means what? Create the Docker container from the current path. Create the Docker container from the current. That means whatever inside there in this current path, right? You put everything inside. You put everything inside your Docker container, right? That's what our point by running this command docker build -t. Then dot. Dot means keep everything. Take everything from this current path. But same thing I am saying here. Pick everything. Dot means what? Pick from the current path. Then Docker file, you know Docker file name is this one, right? Docker file. So I'm just telling, pick this Docker file. Now let's say you want to change the Docker file name, you want to give any other name, Docker file, then something like Docker file, let's say, just rename it like this, Docker file, then new, let's say. You just have to change it here, Docker file, just new, so that you understand that which Docker file you are talking about, right? Then image name, Iris ML app latest. Container name, Iris app. Restart unless stopped. You only have to restart it jab tak it will not get stopped. Okay, then what is the port? Like -p we pass, right? Port binding that we do. This is the host port, this is the container port. Then the network, in which network it should happen, and this will happen through custom bridge network. Now then which volume it will happen, and can you see I am saying create a volume called Iris models, and you only mount the data that will be there inside the app/model. So inside the model folder, whatever data will be there, you store them here. Then environment. Environment is what? There are few paths that we need to store inside our environment, like the model path, like the scalar path, like the port. So we are storing inside this environment. Then the health check command. Okay. Then the interval, in which interval it will do the health check. That means in which interval it will execute this command, nothing much. It is just saying in which interval it has to execute this command. Okay. the network, which will be the network iris net network bridge driver, and I'm saying volume should be iris model, driver should be local. That's all. And now if I quickly go back to my Docker, and I quickly delete this thing, okay, delete this one, delete all the containers, and then I delete the image also. I'll delete the image also. Okay. Okay. Hold on. I think my container is still deleting. Okay. Let me stop it first. Maybe then I can delete it. Let me just try that. Hold on. Okay. I have to stop it here first. Got it. Yes. I believe now my browser has also nothing. Okay. Okay. I guess now I can forcefully stop it. Can I? It should be stopped, or like delete it, whatever. So I believe it will be able to do it. Okay, just stop it. Okay, now it should be okay. I can delete it now. Delete it. Okay. So give it a second. It will be deleted from my laptop. You can see I have deleted all the containers and I delete this image also. Okay. So now if I execute the command called docker compose up, I just expand this and enter. See, now it will be doing everything by itself. It is pulling the iris app. See, again, it is not able to do it, so it is trying to do it from my laptop now. See, it is exporting the image. It is doing everything. See, exporting the image, exporting the layer. It has done everything. It has created this app. It has created this network. It has created the volume, and container iris app is also done. And you can see the server is running right now. And if I go back to my if I go back to my this one, can you see again the app came container? Can you see iris app is there under docker, right? And if I try to execute in 8000 port, localhost 8000, see iris app is running. So this is the power of compose, docker compose file. It can do a lot of things. It can make your life a lot better. But you know, right, this is a very simple app that we have built so far. But when it's about building something bigger, right, can you feel the power of this docker compose? Like, you just have to write a simple YML file only one time and it can do its job by itself in few lines. I mean, not even few lines, in one line it can do that. Isn't it so amazing? Okay, so let's go back to the deck now, and here I'm just showing you. So you can see in my compose command I had these commands, right? So right, one file, one command, docker compose up. But now if I do not use compose, I had to run these 4 commands line by line. First create the network, then create the volume, then run the image as a container, and also add this network, right? So 4 commands every time in order. So whenever you want to run your this entire stack, you needed to run these commands every time. But now since you don't have to do that, that is why we have a something called YML, docker compose YML. Okay, what is the anatomy? You can see first we mention the version, then we mention the service, every container you want to run. First of all, name you choose, then which layer you want to build, which image you want to pass, which port you want to pass, which network you want to pass, which volume you want to pass, what environment variables you want to inject. Like, depends on something, restart, health check. And if you want to create network or volume, you can make their names separately here. So this is the anatomy of the docker compose, and you can keep it handy whenever you want to create it. Okay, visual example simple. This is the diagram in your docker compose YML, where you can see you have the main stack of services. Inside your services you have your app, and your app has this thing, build the docker file in the root folder, then do port binding in this 8000:8000, create a network iris net custom bridge network in your app, then create a volume iris models volume, okay, and restart and stop. If you are stopping your container, it will restart it. Okay, and this is separate, network and volume. So separately it has created networks and volumes, and then we have attached this network and volume inside my app, which is under services. So this is the visual example of it. I hope you have understood it so far. Next we talk about the Docker security, and this is the final topic that we discuss about Docker security. Okay, so Docker containers have transformed how applications are built, shipped and run, and it is pretty fancy thing, right? It is pretty fancy thing. However, containers are not inherently secure. They share the host kernel, making proper security configuration essential to protect production workloads. So when it's about building something in production, security is the most important thing that you need to know, because you know, right, it is a something that can do magic, right? Like your container can contain a lot of information about your company. So maintaining Docker security is something is very important. That is why I kept it as a last topic of our discussion. So let us understand the threat model. Let's understand what threats we have first of all, then only get it right. The first thing is container escape, exploiting kernel or runtime vulnerabilities to gain host access. What does that mean? So let's say, what does it mean, a container escape? So let's imagine that you are in a jail cell, but there is a secret tunnel in the floor that leads outside. A container escape is exactly that. A bug in the Linux kernel or the container runtime like runc lets a process inside the Docker container dig through the tunnel and land on the host machine with full root access. So container escape is nothing but it is, let's say, like just for example, that you have a bug in the Linux kernel or the container runtime, okay, and it lets a process inside the Docker container dig through that tunnel and land on the host machine with full root access. It can happen. And like for example, in 2019, a real bug called CBE20195736 let attackers override the runc binary on the host just by running a malicious container image. Once on the host, they owned the entire machine, not just the container. See how I would say scary thing it is, right? Like this container escape is simply exploiting your kernel or runtime vulnerabilities to gain host access. What they did, there's a bug called CV2019, and this was able to attackers override the runc binary on the host, and because of that, they owned the entire machine. This is pretty scary thing. So this is the threat model, container escape. So you need to make sure that it doesn't have this kind of issues. You need to fix all kind of bugs that are there inside your Linux kernel, because mostly, right, when it's about building Docker or deploying your app through Docker, right, you use the Linux thing only. You use Ubuntu, you use Debian, right? These things are images of Linux only. So Linux kernels, you need to make sure that you are using it properly so that you will not have issues like container escape when it's about production deployment. Next is about image supply chain attacks, pulling malicious or tampered images. You know, right, these images are there on Docker Hub, right? And by any chance, if you have pulled any malicious or tampered image, then you may have image supply chain attacks. Again, with example, I'll explain. Think of it like ordering a sealed medicine bottle from an online store, but a bad actor swapped the contents before it arrived, and the seal still looks intact. Like let's say you have pulled Python latest from Docker Hub, not knowing someone pushed a tampered version from that includes a crypto miner or a reverse shell baked into a hidden layer. Okay, like if I just go and Google and I just show you, like if I just show you Python latest, Python Docker Hub, if I Google, see you can see Docker official image mentioned, right? So this Python is something that is official in Docker, right? And you can see its details here, right? You can see all its details here, you can see all its versions here. But if I just go to explore and if I search Python here, Python, let's say, see, I am getting Python from multiple places, right? See, Python is there from multiple, like clean start, chain guard, active state, stagex, rule, and all this, right? But out of this, you can see it has a tag called Docker official image, correct? So you are more likely to choose this one, or Docker is recommending this one, you can choose this one also. But you are less likely to choose other options because these things might be tampered. Again, I'm not sure these things are verified, it is saying, but let's say it is not in Docker's official image, it is from someone else, correct? These things are from someone else, though they are verified publishers, but it is not from the Docker official thing, it is from anyone else. Since it is from anyone else, it can be malicious, it can be tampered, correct? But you have to make sure that you pick image from a right place from Docker Hub. If you are not doing that, in your case you may have image chain malicious issue, okay, or image supply chain attack issue, okay. So simple, you have pulled Python latest from Docker Hub, not knowing someone pushed a tampered version that includes a crypto miner or a reverse shell baked in a hidden layer. Since you trust that image name, you run it happily in production. The malware runs silently alongside your app and it ate all of your data without letting you know about it even, okay. Next is privileged container abuse. Containers with excess Linux capabilities. What does that mean? Imagine giving a guest in your house a master key to every room, the basement and the fuse box, just because they needed to use the bathroom. Do you think it makes sense? If your guest needed to use the bathroom, you just have to give them the access of your bathroom. Why do you need to give them the access of every room? No, right? Like when I run the command running docker run dash dash privileged gives the Docker container really all Linux capabilities, including the ability to mount the host file system, load kernel modules, and talk to hardware devices. If you run this command like that, it gives all kind of access. And you know, right, these containers are based on the Linux kernel, right? So Linux commands will work on that system. And if you can execute Linux kernel in your production system or in your root system, then hackers can do anything with the system, right? They can transfer your data, your host file system data into their system if they want to, since they have the root access of your system, correct? Like for example, an attacker who gets the code execution inside a privileged container can simply run mount this command and read or write the host entire disk, including the SSH keys and passwords. So if they run this command, right, they can get all the kind of information, all kind of secrets, all kind of SSH keys, all kind of passwords of your system, and it is very risky. It can cause a lot of issues for you, right? So you need to make sure that you give minimal access. You need to give as minimal access as you can, okay. Again, we will discuss more about how to fix the threats, but first of all, I am giving you the idea what kind of threats can happen, and after this I'll give you the idea how we can fix or how we can stop these threats, okay. Next one is secret exploitation. Credentials baked into image layers or environment variables. Like think of writing your ATM pin on the back of your bank card. Even if you lost the card for just a moment, that pin is now exposed forever. Simple, like you have written your ATM pin in your back of your bank card, and like if for few seconds if someone able to access that card, access the bank card, right, they can see your APN pin, correct. So like when developers put secrets in a Docker file like env, like I have showed you, right, when I was executing that command for Postgres, I was running something called -env, right, like let's say env db process super secret. That value is baked into every layer since you have run that command inside your code, right, and because of that value is baked into every layer permanently. So now this data is stored inside your layer. Since you know, right, Docker, when I execute any command, it goes through the layers. So your layer will have this information, the layer will have this password. So even if you delete it in a later layer, anyone who runs the Docker history, my image or pulls that image can read that information, which is not correct, which can be a very serious issue. Like a developer pushes their company's Docker image to a public repo. A security researcher runs Docker history and finds AWS credentials sitting in a layer from 6 months ago. Now anyone who have checked that image which is there in the public repo, they can run the Docker history and they can check the AWS credential and they can log in and they can do whatever they want, right? So you need to make sure that you are maintaining this secret exploitation. Then the last thing called lateral movement. compromised containers pivoting to other containers of the host. Like let's say imagine a thief breaks into one apartment in a building, and because all the doors inside share the same master lock, they can walk into every other apartment too. Like by default, all containers on the same Docker bridge network can freely talk to each other. You know, right? So if an attacker compromises your public facing web container, they can immediately start probing your internal database container since they're in the same network, your Redis cache or your admin API, none of which were ever meant to be reachable from outside. Example, web app container gets compromised via a SQL injection. Attackers then scans the internal network, finds the PostgreSQL container on port 5432 with no password and dumps the entire database, all from inside Docker's default network. So you need to make sure that you do not do that way, because if you do it that way you may lose your data. So you need to maintain this. So these are the possible threats that can happen. Right? Now let us understand how can we stop these threats. First thing, choosing a minimal base image. So always start from the smallest possible base image to reduce the number of installed packages and potential vulnerabilities, because these packages contains the vulnerabilities. So try to use a minimal base image so that you don't have to install too many packages, or because of that you will not have too many vulnerabilities. So like use distortless images for production. They contain only the app and its runtime dependencies. Use Alpine Linux for general purpose images. It is roughly 5 MB and has fewer installed packages than Debian Slim. Avoid Ubuntu latest or Debian latest. Avoid this latest wala thing, latest wala tag in production. They include unnecessary tools like curl, bash, etc. that attackers can abuse. For Go, Rust or C binaries, consider scratch empty image as the final stage. So these are the steps that you need to maintain. Choose a minimal base image. Next, like just for a visual understanding, you can see you should not use something called this from Ubuntu latest. Like you write inside your Docker file, right? From something then something, right? So make sure that you do not use the latest one. Okay, even you can use the slim variant, or the best use if you use the distoless variant, no shell, no package manager. Best to use this distoless wala thing for your safety. Okay, but do not use the latest one because it has a large base with shell and tools, so it will give hackers a lot of opportunity to do something with the system. So do not use them in production. Okay, so then again, multi-stage builds. Multi-stage builds allow you to compile and build in a full environment, then copy only the required artifact into a minimal file and image, eliminating compilers, source code and build tools from production. What does that mean? Like, can you see? Instead of doing everything in one shot, why can't you do multi-stage build? So in the first stage, what you can do, copy only the required artifact into a minimal file and image. So what is happening in this example? If I show you, this is my first stage build, and so in this stage I am only training my model. In this stage I am only training my model, and in the second stage, which is the lightweight interface, because see, this training thing will not be used, right? This inference thing will be used, because after training I will get that model, and that model only I will be using for the prediction, right? And my app only will be doing the prediction, correct? So why I need to keep both of them together? Let's keep it separate, right? So if I do the stage 2 lightweight inference, right, in this case you will have less image size also, as well as you have less data to show, right? You have less data to show, and it's actually good thing if you follow multi-stage builds. Then running as non-root, like by default Docker containers run as root. If a process inside the containers is compromised, by any chance if your process is compromised, the attacker has root level access within the container and potentially on the host if other controls are missing. So since Docker containers run as root by default, it's a very I would say scary thing, right? By any chance if your system is compromised, then your whole system gone, right? So instead use some non-root user, create a dedicated non-root user by running this command. Create a dedicated non-root user, then let that non-root user does the other things. If you do that way, you are safe, because now this non-root user has only specific access. It does not have the admin access, right? So that is why it can safeguard you. That's why it's always suggested that running as non-root user. Okay. Then immutable layers and Docker ignore. So Docker ignore file prevents sensitive files from being accidentally copied into an image, like environment, like you can see .env, .key, .pem, secret folder, node modules, Docker file, Docker compose YML, .git. Like these things I do not want to push inside my Docker container, right? Since I run Docker run dusty dot, so dot does everything from the current root path. So if you create a new file called .docker ignore, and if you pass this folder path or the file name or something, right, then it will not push those data inside the Docker image when it will create that image, right? By using Docker ignore, what you can do, you can simply prevent sensitive files from being accidentally copied, just like git ignore prevents files from being committed to source control. So you can use Docker ignore to make sure that you do not push any I would say any sensitive data inside your Docker image, because tomorrow if your image is getting compromised, your secret or your sensitive file should not be compromised, right? Then image vulnerability scanning. So there are multiple options that you can do. So scan images for known CVEs, common vulnerabilities and exposures, before pushing to a registry or deploying. Intricate scanning into a CI/CD pipeline to catch vulnerability early. So Trivy, GRIP, Docker Scouts, this container, these options you can use to check your image vulnerability scanning. And this is one of the coding example that I have showed you here. Okay. Then let us understand how we can stop stress container runtime security. How we can stop stress using container runtime security. So keep read only root file system. You just keep read only root file system. So mounting the container file system as a read only prevents the attacker from writing malware, modifying binaries, or persisting changes if they gain code execution. So since you are giving read only root file system access, so they will not be able to write any malware because they do not have write access. They cannot modify the binaries, they cannot do anything. Okay, so this is the way that you can do that. You can see I have mentioned here in this case. You can see docker run dash just read only my app latest. I'm saying run this thing on read only. This is container runtime security. If you want to maintain container runtime security, you can do that. Run things on read only always. Okay. Then dropping Linux capabilities, as I've discussed, right, that by default if you use latest options or something, by default your container, you will have the access of all Linux capabilities, and you do not want to do that, right? You do not want to do that. So that's why you are saying what Linux capabilities divide root privileges into smaller units. By default, Docker grants a set of capabilities that is far more than most applications needed. So you do not need that many capabilities to have. You do not need that many capabilities to have, and that is why drop all capabilities and add back only what is required. So what is required? You only give that much access to execute. You are not giving too many things to execute. You are not giving it unnecessary things or unnecessary capabilities to execute. You are giving only those capabilities, whatever capabilities it needed. Like you can see, drop all capabilities, add back only what the app needs. Like when I'm running this command, right, docker run, here I am saying cap drop all. So drop all the capabilities, and I am saying cap add net bind service. What does that mean? Net bind service means ports lesser than 1024 allowed. So whatever ports are there till 1023 will be allowed. Okay, so this is the another way how you can drop Linux capabilities. Security profile. So CCOM app armor provides mandatory access control to restrict file, network, and capability accesses. So Docker applies a default seccom profile that blocks approximately 44 dangerous syscalls. Okay, use custom seccom profile to further restrict only required syscalls. App armor profiles are applied automatically on Ubuntu or Debian hosts. So these are the security profiles that you can apply, and you can see the commands for that. Okay, resource limits. So you can, without limits. A single compromised container can consume all the host, CPU and memory, causing a denial of service across all containers on that host. Always set resource limits. If you do not set resource limit, and if by any chance your container is compromised, they can eat your whole CPU and memory, right? So before that, because of that, what you need to do, you need to make sure that you need to measure the resource limit like docker run, then the memory size, your hard memory limit like 512 MB, then memory swap 512 MB, you are disabling the swap, okay? Then CPUs, maximum 1 CPU core, what is the maximum process, 100 maximum process. So you can limit your resources like this while running your container, okay? So this is kind of these are the ways you can maintain the security while running any container, okay? Then network security. So you can see custom bridge network, right? Docker containers on the default bridge network can communicate with all other containers, we know that, on that network. Now use custom bridge network to create explicit isolated communication segments. You know how to create a custom bridge network now, and you need to maintain this way only. Do not trust on bridge network in production because it works by default, and under that network all containers can communicate. You do not want to do that. What you want, that I create my own custom bridge container, and inside that container my app will be running, my app stack will be running, and other app stack will be under different network. And because of that, if by any chance one container is getting compromised but other app stack will not be getting compromised because your networks are different, okay? Then limiting exposing port. So only expose ports that are genuinely needed, because you know, right, expose, if you mention the expose, right, it doesn't actually create anything, right? So only expose ports that are genuinely needed. Use expose in Dockerfile for documentation, but -p for runtime binding. So bind to localhost for services that should not be publicly accessible. You have to make sure that if you want to make sure that your app should not be publicly accessible, use this localhost port, like after -p, use this localhost port. It is good thing, okay? Use this port instead of 008080 port for admin interfaces, okay? Then let's discuss about secret management, how we can maintain the security. So secrets baked into the images are a leading cause of credential exposure, like that environment variable example, right? I was passing this password while running that container, which is a pretty risky thing because that information now stored inside my Docker layers. If anyone checking my Docker layer history, they can easily access my credentials. So because of that, you need to maintain the secret source properly. So once in an image layer, they remain recoverable even if deleted in a later layer. So what you need to do, you need to make sure that you have to make sure that you always use .env files. You always use .env files, and inside .env files only you keep your all the information. Do not pass the secrets like this way, okay? And that's all. So that's all I had today for Docker, and Docker is completed now, guys. So I hope you guys have learned a lot about Docker, and I hope I was able to explain to you about Docker. And I hope you are liking my video, and please make sure that you complete other videos that is available inside this MLOps playlist. And I hope you will be having a good day after completing this video. So thank you guys for watching this video. We'll catch up next time. Bye bye.